All right.
Does anybody have a number that has not been written down?
Okay, number one. I need some help up here. All right, the winner of the competition here, number one, is Glidden Dolman. And the next one up is Peter Wright. So, Peter, you could be preparing. Glidden just gave me a video. Do you want to make any remarks about it?
I won't waste the time.
Okay.
It's all my voice. Badly done.
All right, this is Mr. Glidden Dolman, who was a real pioneer.
59 years so far. And still in it. I'm sorry, that thing needs rewind. Did you start or at post-war?
And do you have many students?
If we could get this room for the next 3 days, I think we could have much of this material going on. Thank you, Glidden. Very interesting. Peter Wright is next on our schedule. He's got a video here about the museum. There's several museums now where we can go and see our history, and the one in Westchester, Pennsylvania certainly is the big one now. Peter, you want to say a few words, and then we'll run your video.
Well, good morning. Nice to be here. And I just wanted to tell you a few things. This is supposed to be a pioneers group. I suspect that a large number of you folks here are engineers or designers or manufacturers. I don't know whether I'm a pioneer or not, except I've been in the helicopter business for 56 years. But I have been entirely, with a small exception, short exception, in the commercial operating end of the helicopters. Most of the people I know are, at least in the American Helicopter Museum that I represent, most of our volunteers, and we have about 250, are engineers or designers or manufacturers. And I like to tell them that I'm not an engineer, I'm not a manufacturer, I'm just start off as a helicopter salesman, I guess. Anyhow, I like to tell people that anybody can design a helicopter. That's real easy. Nothing to it. The real trick is to make money with it. And I don't mean sell it to the military, although that's a good way to make money. I mean take it out and take a machine and take it out and get people to pay you to use it in their business or for whatever they're doing. So anyhow, that's my business. I started off by joining the Navy back in 1939 and learned to be a pilot down in Pensacola. And I was on an aircraft carrier for a year or so. And I resigned from the Navy in 1941, went out to China and flew for a year with the Chinese Air Force. Then I came back in 1942 and flew the Atlantic for 4 years, 2 years flying Sikorsky flying boats. So Sergei's here somewhere, and I think he remembers those and some of the exploits with his dad. But anyhow, in 1946, I was flying out of LaGuardia Airport at the time. That was before Kennedy was built. I came home to Philadelphia, where I lived, and my father said there's a new gadget that's been flying around here called a helicopter. Have you ever seen one? And I said, well, I don't think I've seen one, but I don't know much about them, and I don't think much about them. And he said, well, they're starting up a new company in Philadelphia, and they're going to fly out of Camden Airport, because Philadelphia didn't have an airport in those days. And So I jumped in my car and went over to see what it was all about. I arrived over in Camden, New Jersey, and found there was a company called Helicopter Air Transport. First commercial operating company in the world had started up. I went in to see the head guy that was running it, Norman Edgar, whom some of you may remember, and asked him what are they going to do with the helicopters? And he said he didn't know. And I said, gee, I never went to business school, but it sounded to me like he was starting it up sort of the wrong way. But in any case, after about 2 or 3 hours and a flight in a Bell 47 by Joe Mashman, he'd just flown in to deliver one of their Bell 47B models. He gave me a ride, and it's never happened to me before in my life, even when I got married, that I ever fell in love just immediately. I fell in love with a helicopter, and I've been in it for 56 years. But in any case, I had a wonderful experience flying. I didn't fly. I decided I wanted to get out of flying. I was a senior airline captain, and I didn't think there was much future in the airlines other than just flying, which was okay. But I wanted to get into something else, administration and sales and so forth. So they hired me as a salesman. And I had an opportunity to fly and get checked out, but I decided not to. I had a theory that you ought to stay current in your aircraft if you were flying it. And I didn't think I'd do that with a helicopter because I was so busy running around trying to get business. To make a long story short, we got a lot of interesting jobs. The most interesting thing, and I believe the most important one that I ultimately sold, was selling the first oil exploration job ever done by a helicopter in the history of the world, as far as I know. It was in 1946. I sold a contract to a geophysical company in Louisiana that was working for Standard Oil of California. The problem was they were doing a magnetometer survey, you've got to put a little magnetometer, put it on the ground every quarter of a mile or so forth in a marshy area in Louisiana. And the work was being done by marsh buggies. They were great big machines with huge big tires, very slow. And the important thing is, or the important thing to the helicopter industry was, that these big tires would squash the what were the name of those animals that they were hiring? Muskrats. They were raising muskrats. And the big tires had squashed the muskrat huts, little bumps in the earth. And so the muskrat farmers tried to stop the oil company from exploration. But even with that problem, it was a terribly slow job moving around with these great big marsh buggies. We came in with a Bell 47B model, which could only hold a pilot and one passenger, and the magnetometer, which fortunately only weighed about 50 pounds or less. And we showed them what we could do. And I was absolutely amazed. We trucked this helicopter down to Houma, Louisiana. We started flying it. We started the job. And all of a sudden, people came in from all over the world, from South America, from Asia, from all over the United States and Canada. They're all geophysical people wanting to see what this thing was about. We were on the job for about 3 or 4 months. It was supposed to take 1 month. We had to change engines. We changed the transmission 2 or 3 times. We had the usual problems that you have starting out. But when we worked, we did as much work in 1 day as a marsh buggy could do in 3 weeks. And it just revolutionized the business. Well, while I was down there, the company went bankrupt. I was stuck down there. I'm still waiting for my last paycheck. But in any case, I came back. I went up to see Larry Bell. We were the only helicopter operating company in the United States at the time. I went to see Larry Bell, who I got to know pretty well, up in Buffalo, about starting up a helicopter company to take over this work, because the oil companies wanted to continue it. He agreed to help us, but the insurance rates had gone up to about 30%, hull insurance. I couldn't get anybody to finance me. I didn't have any money. And so I just got out of the business, and I went to work for Frank Piasecki for a couple of years, working with Harry Pack and trying to sell the HUP to the Navy, which turned out to be successful. any case, that was a fascinating experience, and I fell in love with the helicopter business, and as soon as I could, I started my own company. In 1953, I started Keystone Helicopter Corporation with $50,000 and one used Bell helicopter. Today, Keystone Helicopter is the largest and the oldest, and I'm almost sure the most profitable commercial helicopter company east of the Mississippi. We have about 360 employees. We do roughly about $75 million worth of work a year, and it's a good little company. My two sons run it. But any case, when my sons took over the company, I decided that I'd get out of the business as far as running the company, and I got together with a bunch of guys in Philadelphia, and we talked about starting a helicopter museum. The discussion came up because of the 50th anniversary of the American Helicopter Society, the group we're sitting with today. And the people in Philadelphia wanted to make a big splash, so they said, let's start a museum. And I said, well, the 50th meeting was in about 4 months. And they said, well, that ought to be enough time. Well, I don't know if any of you people started museums, but 4 months, maybe 4 years is a short time. Anyhow, we got together and we started the American Helicopter Museum. We consider it the first and only true helicopter museum in the United States of America, or in North America, now that we're up here in Canada, in North America. We started in 1993 and formed the company. And in 1996, 5 years ago, 5.5 years ago, we opened up for business in half of a rented hangar in Westchester, Pennsylvania. It's the site of the old MBB helicopter facility. As many of you know, MBB merged with Aerospatiale and moved down to Texas. So we rented half of one of their hangars, 35,000 square foot hangar. We started with 20 helicopters, 3 of which were on loan from the Air and Space Museum, the Smithsonian. Frank Piasecki's PV-2, the oldest Bell helicopter, Model 30, and the XR-4, the first production helicopter, I've been told, in the world. Along with that, I had collected a number of helicopters, so about 8 of those have gone into the museum. And then we have some that have been donated to us by individuals and on loan from the Air Force and the Army and the Navy and the Coast Guard. We presently have 36 helicopters on display. We have 4 paid employees. We have 250 volunteers, and they're the life of the museum. Without the volunteers, there wouldn't be a museum. They put in these volunteers over 135,000 man-hours of free labor. We have had about 135,000 people go through the museum. One of our selling points, you might say, besides the fact that we're a unique facility, and we don't have any fixed wing, just rotary wing. What we do is we let the children, go through as many helicopters as possible. 8 of them are set up where the kids climb inside, work the controls, throw the switches, literally destroy them if you're not careful. But anyhow, the kids just love this, and their parents love it, and the teachers and so forth. We have a strong school set up. We're working with the local schools. This year so far, we've had 420 Head Start, little kids, little bitty kids, 3 and 4 and 5 years old, just love helicopters. As most of you know, there's a big shortage in the United States of helicopter pilots, mechanics, engineers. And if we don't get these kids in the early ages, in the young ages, interested in our business, aviation, and helicopters in particular, or rotary wing, we're making a big mistake. And we think we're doing our part, and we want to continue and grow. We've outgrown our facility of 18,000 square feet. We're now in the process of buying the building that we're in, which is 35,000 square feet, knocking the curtain wall down, and so we'll double our space. We have a $4 million capital campaign, which just started up. We've had $500,000 put in by members of our trustees and friends. And a couple of months ago, or last month rather, in May, I flew out to California and picked up a check for $1 million from a helicopter manufacturer. And you'll be interested to know it was not Boeing, it was not Bell, it was not McDonnell Douglas, it wasn't Sikorsky, it wasn't all the nice European manufacturers, Eurocopter and so forth. It was Frank Robinson. If any of you guys know Frank Robinson, if you don't know him, when you see him, go over and shake his hand. He's a wonderful guy. He's my best friend right now, I'll tell you the truth, after the $1 million. But in any case, he's a great believer not only in the helicopter business, obviously, in the future of it, but in getting people into it, getting younger people into it. And he also gave $1 million to the Air and Space Museum a couple of years ago. So we like to say, you know, the American Helicopter Museum and the Air and Space Museum are on a par. You know, we're equal. They're a little bit larger. I want to show you just a few minute show, but I want to mention three things that we're interested in. Number one, I'd like to mention that John Schneider, one of the great things that happened to us, besides the Air and Space Museum offering us these machines when we had nothing, no, just a paper museum, they had enough faith in what we were going to do, was the fact that I met John Schneider. I'd never met him before. He, of course, retired from Boeing, and he became our official historian. And he was a tremendous help to us. I mean, Ray or whoever it was started off, Dan Newman said that he knew everything and knew everything about helicopters and where to find out about any old antique helicopter. Well, he sure did. He was a tremendous help to us because we've had a lot of pieces and parts and old helicopters offered to us, and some of them we had no idea what they were. But John always knew, and he was just a wonderful guy. And not only that, he was a wonderful gentleman. Anyhow, the three things I'd like to mention is, number one, membership. We have over 1,000 members, but we need more members. Members are a big help to a museum, and also the museum can be a help to the members. We keep you posted on what we're doing and so forth. I'd like to ask every one of you and any of your associates to join the museum. I'll leave somewhere around here some booklets on membership. It's $50 a year, and you'll be doing something to, besides all the other things you do, to help the helicopter industry. The other is archives. We have 10 volunteers and 6 or 8 computers working on our archives. We have thousands of pictures and photographs, manuals, all kinds of things, models, original artwork, and so forth. We're very anxious to increase all that. We'd like you all to think, as you get a little bit older, I had a birthday last weekend. I'm 85 years old, and I'm starting to think about what might happen when I go to this big helicopter hangar in the sky. But I'm going to leave all my stuff to the American Helicopter Museum. That's pretty obvious. But one of the reasons I feel confident about it is Ray Prouty, 3 years ago, wrote me a letter and said he had quite a collection of helicopter materials and so forth. Obviously he does have, and he's leaving it all to the Helicopter Museum. So any of you folks, any of you ladies and gentlemen out there might keep that in mind. Not that I want to talk about what might happen, will happen to all of us sooner or later, but just keep us in mind, or anything, and if you retire that you're going to toss out, and your wife's going to toss out, or your husband, in a dumpster, why, call us, and we'd love to come and either come and get it or send it to us, because we like to collect almost anything about the early days of rotary wing. The other is, and I don't like to end up on a sour note exactly, but we are in a fundraising mode. We've raised $1.5 million out of the 4 we're trying to raise. So if any of you folks would like to reach into your wallet and give us a little help, we'd certainly appreciate it. And so with that, I'm going to turn on the show and show you a little bit of what we're doing.
Should I, Jennifer? take off and land in small areas.
How about the
However,
light? Turn the
these
light on.
designs were required to fill special needs. Some rotary wing aircraft were designed to not only land in tight areas, but hover and fly sideways and backwards. By the 1970s, helicopters were a vital part of everyday life, from transporting troops to repairing high-power wires or fighting fires. Today, skies are filled with helicopters, reporting on traffic or speeding accident victims to hospitals. Because helicopters can fly where nothing else can go.
Idea. Thank you very much, and if you have any questions, I'll be around and be happy to talk to anybody. Thank you.
Thank you, Peter. If you get a chance, go to that museum. It's really an eye-opener. And as he said, I wrote a letter and I said, send a truck when you hear that I don't need my stuff anymore. So they've got the truck set up, I think, right now. All right. Our next event is Sergei Sikorsky. Maybe some of you have heard this program before. I've heard it 2 or 3 times, but it's always interesting. So, Sergei, you're on. The computer, they've already aimed it and focused it.
Thank you, Ray, and good morning, ladies and gentlemen. In view of the slightly compressed time, I took a chance without further ado in shortening somewhat the recollections of a pioneer, because A, a number of you have heard it, B, there are a number of speakers that will be coming up whose stories are also so important and far more qualified to talk about helicopters than I am. I would like to talk about the helicopter and about Igor Sikorsky and about his beginnings. It's interesting, when you think about Igor Sikorsky, we think about a test pilot first, a wonderful stick and rudder man. I had the privilege of flying conventional aircraft with him on a number of occasions, and that man was very, very good, both in fixed wing and in helicopters. He also was a philosopher. I'd like to share some of those philosophies with you here as we go through the development of the VS-300 helicopter. It's interesting in his words to note that at least 3 types of flying machine could have been built and flown successfully 2 to 3, possibly 4,000 years ago. We have seen in the museums the woodwork and the battle carriages and the weapons of the Greeks, the Romans, the Assyrians, and the Chinese. And in the words of Igor Sikorsky, there is no doubt that the technology was there, the sinews, the glue, the cloth, the varnishes, so that at least 3 kinds of flying machines could have been built and flown 5,000 years ago. And these are the hot air balloon, the large man-carrying glider, and a large man-carrying kite. However, mankind could invent and dream, but could not make it work, probably because of the fact that at that time the current wisdom was that man would never fly. And if you are convinced that you cannot fly, then certainly you never will be able to fly. My father was particularly interested in the Egyptians, who had probably the closest idea of required wing area, and also, terribly important to fixed-wing people, aspect ratio. If you take a look at some of the aspect ratio of the wings that they created, whether this is art or whether this is science, you realize how close these people were, at least the artists, intuitively, how close they were to science. There is not a culture, there's not a people, no matter how advanced, no matter how primitive, that did not have their dreams of flight. It's also interesting that mankind first tried to imitate the birds, also the sketches of Leonardo da Vinci. It is also interesting to remember my father would quote the words of a great Russian scientist, Professor Zhukovsky, who said on several occasions when talking about mankind and his first attempts to fly with the ornithopters, or man-powered flapping wings, the very, very beautiful phrase that man will fly. Now, mind you, this is 1885 that he made this statement. Man will fly, not by the strength of his muscles, but by the power of his mind. And I think these words start the era of the Lilienthal's, the Adair's, and all of the maxims that contributed so much to flight. They also postcede the work of Leonardo da Vinci and a number of other great artists. The helicopters went through a number of variations, and eventually, along with hot air balloons, at the turn of the century, we can say that there's no doubt that the Wright brothers conquered heavier than air flight. And immediately with the conquest of heavier than air flight, aviation became possible. It is, of course, interesting to note that Paris was at that time the center of aviation, but aviation was neither an industry nor a science at that time. It was probably closer to an art and a passion, and to many a miracle. Igor Sikorsky started with the helicopter, his first love. And in 1910, when he built his first machines, he later would characterize these aircraft as follows. The lack of success of my first two helicopters was due to two factors: lack of horsepower and lack of know-how. And basically, that's what it stood. He also gently explained at that time that even though the catalogs listed the early engines in 12 and 20 and 30 horsepower, my father secretly insisted that this was actually 20 or 30 dog power, possibly even cat power, because of the fact that the brochures, to put it mildly, were terribly optimistic as to actual horsepower delivered. The intensely romantic period of aviation is followed. It is interesting also to realize in those early days, think of it, that from the first flight of the Wright brothers to the first flight of the Grand, and shortly after that to this Ilya Muromets that you see here, was 10 short years from the first hop of the Wright brothers to this, the first four-engine, fully enclosed cabin airplane. A unique aircraft, and yes, there is a man sitting on the wingtip of the aircraft out there, Vladimir Panasyuk, the chief mechanic and an old friend of my father's. This aircraft, in my father's words, was very unique. It took off at 60 kilometers, it cruised at 60 kilometers, and it stalled at 60 kilometers. But other than that, it was a very successful and interesting machine. In those very, very beautiful early days of aviation, there was a number of phenomena. One of the phenomena, in my father's words, was the fact that the early engineers were almost always the early test pilots. This had the fortunate result of eliminating poor engineering very early in aviation. Other words that are just as true today as they were in those days, the words of a great French pioneer, Ferdinand Ferbert, when he said to young Igor Sikorsky, 1910, "To design an airplane is nothing. To build that airplane is very little. But to test it and develop it into a successful machine, that is 95% of the challenge." That, ladies and gentlemen, is still as true today as it was then. It's interesting to notice also to the engineers and the test pilots in this room that the load factor of the Grand was, believe it or not, an incredibly fragile 1.5. But in Igor Sikorsky's words, he said it was probably more productive to fly and demonstrate the four-engined aircraft at a load factor of 1.5 than it would be to stay safely on the ground with a load factor of 2.5 or 3. And consequently, he did it. Then, with the end of the series of the Ilya Muromets, Igor Sikorsky came to the United States, started to dream of flying, built a number of successful aircraft, and already in 1928, 1930, the first sketches begin of a new helicopter. The 1920s were also, and the 1925 were also the days of the starvation in aviation. And again, there's the story, Roosevelt Field, Long Island, and a shabby gentleman named Igor Sikorsky, without too much money, but with a great love for aviation, is walking down the flight line. And the next hangar, there's a very tired old training airplane, probably a Curtiss Jenny, warming up, and a very nervous pilot about to make his second or third solo. Igor Sikorsky walked up to this young pilot and said, "Young man, when I started it to learn to fly, we did not know if the airplane or the pilot was capable of flight. In your case, 50% of the problem has been solved." Long ago, as he began to work on the helicopter, I think he remembered the words of an old philosopher who once said that the birds learned something very important many, many hundreds of thousands of years ago. Namely, they learned that it is far easier to stop and then land than it is to land and then try to stop. And airplanes can fly anywhere, but they cannot land anywhere. And consequently, he began to work on the helicopter. It was a hard job. The hardest job of all was to convince United Aircraft to attempt a helicopter, and then on top of that, to attempt a helicopter in a configuration that had never worked before, namely a single main lifting rotor with a small tail rotor. Attempts had been made, Yuriev in Russia, before the revolution, and then, of course, the pioneering work of von Bonhauer in Holland and Tsagi in Russia, but the Tsagi attempts especially were at that time highly classified and secret. At any rate, he remembers the following conversation when an engineer asked him, "When will the helicopter fly as efficiently as the airplane?" And Igor Sikorsky answered, "I know the answer to that, never." "When will it be as fast as a fixed-wing aircraft?" Igor Sikorsky answered, "I know the answer to that as well, never. But," he continued, "the helicopter will be able to do a great many other things that no airplane can do, and in fact no other machine yet invented by man can do except for the helicopter." And so consequently, he followed in the path of Dascagno, and he followed in the path of Breguet, and followed into the path of Heinrich Fokker, and except then he went into the single rotor machine. This, by the way, is the Tsagi single rotor aircraft, two anti-torque rotors, one at each end of the machine, and then eventually the Fokker machine, and now we come to this trainer, the first synthetic trainer as far as I know. We have never been able to find any drawings of the VS-300. We have access exactly 4 sketches. And these 4 sketches are all that we have ever found on the helicopter. Everything else on it was verbal description. Let's do it this way, and let's make it very quickly adaptable to changes. The VS-300, as it originally rolled out in 1939, and then the very first flight, of course, as you see here, and the wonderful chance, in Igor Sikorsky's words, to relive one's life all over again, to design and build a new type of machine without knowing how to build it, climb into the aircraft, start the engine, and start your first test flight without ever having flown a helicopter before in your life. It was, in my father's words, a chance to repeat life as it was in those days. The configuration of the helicopter went through about 200 minor changes, several changes. I'm not going to bore you because of the time here with the changes, but basically you can see it going through a variety of configurations as Igor Sikorsky teaches himself to fly, experiments with the 3-tail rotors, submits a bid to the United States Air Force for a new machine to be called the R4 with the same tail, triple tail configuration as the VS-300, eventually works out on the first public demonstrations. The first Army pilot, Colonel Frank Gregory, starts to fly this machine and says, you know, Mr. Sikorsky has something, and it is coming. Gregory, a highly experienced autogyro pilot, is the first person outside of Igor Sikorsky and Sergei Glukharov who flew the machine. The tilt of the tail rotors is experimented with, and at that time it is considered that something is bothering those 2 rear rotors because vibration starts, and it probably is downwash. Nevertheless, world's records are established very rapidly through 41, 42, and then it goes into the sesquitandem. It's an interesting period of about 15 to 20 flying hours with the VS-300 as a sesquitandem rotor. And you can see here the tail rotor gearbox very, very close to the vertical pylon. On the day that my father was practicing for a demonstration to the board of directors of United Aircraft, he made a somewhat rough landing, boom, and knocked 3 inches off the tip of one of the tail rotor blades, the 2 blades. And of course, absolute panic, because how were we going to fix this in time to show the machine? One of my father's closest friends, an ex-naval officer named Boris Labensky, walked up with a hacksaw and cut exactly the same amount off the opposite tail rotor. They repainted both tail rotor tips, and believe it or not, 3 hours later they flew a very successful demonstration for the board of directors. They did put the tail rotor further out, as you see on the next modification. Again, sesquitandem machine. Then the decision to go to an unlimited, completely cyclical control, main rotor and tail rotor. This is the first flight of the final configuration made December 8, 1941, 1 day after Pearl Harbor. The helicopter proved to be an instant success and began to show greater stability, controllability in flight. And in 1941, 3 weeks after that, was the first flight of the R4. I think to the engineers and to the pilots in this room, I think the greatest proof of the fact that Sikorsky was slowly beginning to become expert in the helicopter was the fact that on its first day of flight, the R4 made 6 separate flights and logged a total of 36 minutes in the air, rather unusual for a first day, first flight machine. The helicopters have gone on to become very, very useful instruments for the saving of human lives. The VS-300 itself, after 3 years, roughly 120 flying hours, was retired to the Ford Museum. It was interesting there at the Ford Museum that Igor Sikorsky was, after demonstrating the helicopter, a little lady stopped him and said, "Mr. Sikorsky, this is a wonderful machine. It does everything possible. It's a magic little aircraft. And Mr. Sikorsky smiled and said, thank you. I think it is a very pleasant aircraft to fly. There was a moment pause. But tell me, Mr. Sikorsky, what happens if the engine stops? There's a pause, and Mr. Sikorsky very politely explained to this little lady the aerodynamics of auto-rotation and the fact that the helicopter can be landed safely. The little lady stands there for a second and says, well, what happens if one of the rotor blades falls off? And Mr. Sikorsky stood for a moment, politely bowed and said, Madam, we do not recommend it. I think I will close the briefing on the life and the work of Igor Sikorsky by saying, once again, he was very proud of the life-saving uses of the helicopter, very proud also of its use in a growing importance among the military, very proud of the fact that it had grown to create new forms of industry. Because I think if we stand for a moment and think of offshore oil, we realize that offshore oil and the drill rigs and the people working on them today probably would be uninsurable if it were not for the helicopter and its capability to go out and save lives. I'd like to close this very, very brief summary of the VS-300 and the helicopter by quoting two of Igor Sikorsky's words, and I think that they are still as true today as they were when he first uttered them. And one of them being, truth in politics is optional. Truth in engineering is mandatory. And the second phrase, that the history of the world has proven time and time again that nothing can replace the free work of free men, because that is where all progress starts. And the third phrase that I would like to leave you with here today, ladies and gentlemen, is a toast that Igor Sikorsky made some years ago. And again, I think those words are still as valid today as they were some 30 years ago, when in Washington he said, let us hope that in the future the statesmen and the politicians of the world will do their job as well as the engineers and the pilots have been doing theirs. Thank you, Ray, ladies and gentlemen.
Thank you, Sergei. That was very good. Our next presenter is Don Segner, a test pilot from long ago, going to use the new technology here. I think it's all set up, Don, but we get somebody up here who knows how to run it.
Do I go over there or do I work from here? You do it, okay. Okay, you gentlemen, it's a pleasure really to be here and talk in to such an elite group. I know many of you, Stratsvici, Dr. Tishinkov. I met Dr. Mill in the 60s, 65 at Paris Air Show, and we were flying the XH-51A compound, which we took 300 miles an hour. But I'm not going to talk about that today. Ray made me promise not to do that. I'm going to cover a period, if you'd hit the next one. I am going to talk about a period of creativity. That's the period when I got placed in the helicopters as a fighter pilot. I did most of my flying in Korea. We were in World War II. I got in the end. I flew Corsairs. I was an early jet pilot, did a tour with the Air Force. Then I was placed in helicopters to try to bring some change in, as a few of us did. And after 10 months, 600 hours, I was sent to test pilot school. And when I got there, I was the only qualified MOS, Military Occupational Spec, helicopter pilot in school, but we got to fly everything. It was heaven for a pilot. We had supersonic jets, we had seaplanes, we had helicopters. But my job was to get through and get into the rotary wing flight test at Patuxent River. So it provided me with the opportunity to participate in a period of the 50s where it was a period of creativity and innovation by you designers. We needed and we got increased capabilities of performance and handling qualities. We had numerous innovative rotor and control system design concepts. We had unique power and propulsion approaches to these power problems. We had unusual approaches to non-rotor vertical flight. We had very minimal design guidelines, little formal flight testing criteria, but we had lots of visionary people. Well, what were some of the needs that drove these visionary people? Well, for the Navy, which we were interested in because I was at Patuxent River, as a Marine, we wanted to increase the anti-submarine warfare capability for the Navy. So we were looking at the all-weather capability of both day and night, flying into and out of a hover in all-weather conditions over the water. Quite a task for a helicopter, and I used to say that a helicopter pilot is nothing but a rate damper, because helicopters were so unstable, and until the SAS came along, or the Lockheed rigid rotor, they remained unstable. All-weather flight capability both day and night, flying into and out of a hover, that's a task. We did that manually for many, many, many months. Or we even looked at alternatives, using water and landing capabilities to see if that would help us with our ASW capabilities by dunking sonar that way and what it would do. What are some of the needs continued? Well, the U.S. Marine Corps needed increased amphibious assault and maneuvering capability. The helicopter was the best way they felt that we could do that. They needed heavy lift, external and internal capabilities. I remember my first time meeting Sergei Sikorsky, or Igor Sikorsky, when he talked about carrying big tanks and cargoes over deep valleys and ravines. But he did it with an accent that I can't even duplicate it. And I thought, this guy, man, is a visionary. We needed to keep the troop together. We needed troop integrity. We needed movement by day and by night. We needed observation control and command and control. And we needed the attack close air support, the VTOL version for our troops. While there at Patuxent, I had the privilege of working with many, many aircraft manufacturers and numerous aircraft machines. I'll cover a few of them today. We had the Alouette come through, we had the Bells, we had the Brantley, we had the Cessna, we had the Doman, we had the Gyrodyne, the Hiller, Command, McDonnell, Piasecki VTOL, and the Sikorsky. Now, those are the main ones. I won't cover them all. Okay. The rototypes tested, oh, I'm sorry, you can click on. Okay, the rototypes tested. We looked at the single rotor, the fully articulate and clockwise rotation rotors. We looked at single rotor non-articulate with counterclockwise rotation. We looked at the syncopter. We evaluated the tandems and tested them, the coaxials and the teetering. So just about every concept that you all came up with, we had the opportunity to test and evaluate, either for concept evaluation or for operational use. Let's go to the next one, please. The propulsion systems. We had the reciprocating. We had the very first, well, we had 2-cycle engines, 4-cycle aircraft tank and automotive conversion engines at that time. You all know them, you had to work with them. What is your biggest problem? How are we going to get the power? The first large twin-engine aircraft Sikorsky in production, which was twin-engine, the HR-2S. The rotor system power augmentations, we used saw compressed air cold-tip jets, compressed air pressure jets, and tip jets of various configurations. And finally, the free power turbine engine, both single and dual. Okay. This, I think, is a unique slide. I had this taken when I was the only pilot there. My boss, who was a Navy commander, was killed in an accident when the blade came off the aircraft. And the other two pilots we had were Navy, decided they wanted to leave, so they did. But at that time, look what we had there. A little bit of history, so I had a picture taken. Here is the HR-2S, which was the largest twin-engine helicopter built in production that time period. We had the HUP, which is the tandem, the early tandem. We had that in two configurations. We had the first syncropter, the HOK, the HUK for the Navy and the Marine Corps. We had the YH-31 hingeless rotor, the Doman. And you notice, gentlemen, it rotated in a different direction than the normal Sikorsky. It followed more of the mill design concept. And then we had the XRON coaxial. And I put this one in because this coaxial is different. It did not use the differential torque that we get, and therefore the negative problem you get with left rudder and right rudder when you're in auto rotation, and the mechanical reverses you had to have. I'll go on that a little bit later. It had tip brakes. Its max gross weight at that time was 600 pounds. The HTL-7 and the Hiller H-23D, we did the Army testing wherever there was a Navy project officer in the plant. The Air Force did some of it, but we did a lot of it. But the H-23D and the HTL-7 were both similar. Of course, one using the Hiller pattern, and the other one using the Bell teetering rotor system with its stabilizing bar. The Hiller, we found, was a little bit better performing. It was a nice airplane for what it was designed for, did a good job, had better performance in hot and humid weather, but Bell was a prettier and flew well, and the Navy liked it better, so it got the contract to go to the Navy to be the training aircraft. There wasn't that much difference in the two aircraft. The next one. This one was very unique in that we had a HUP that was rebuilt by Ito with floats, had a watertight hull, was beefed up, used fiberglass, changed the doors and other things and the structures of it. Turned out to be a very, very fine waterborne type helicopter. Of course, you save power when you're on the water, you save power when you're in ground effect. It could taxi well. It would work well in waves, except when they got too high, you could hit the tips of the blades in the water, so that limits there. We were demonstrating it once. A Coast Guard officer got in it and immediately rolled it over. So that sort of shortened the program. But it was a very successful thing, showing that amphibian stuff was possible. Next one, please. The next one was the S-62, which was nothing but the S-55, or as we call it in the Marine Corps, the HRS, with the T-58. This was demonstrated by Sikorsky. It was a very fine bird. It had a couple little problems. They were very minor. If you did an auto rotation at FCG, it always had to spray up and would shear the tail rotor. So that didn't work out too well for us. Then they took it back, and it did finally get certified, but it was a nice airplane. But they decided at that time that the amphibious portions were not there. We had to go into the IFR flying. So we did that. The H-23, the next one, I guess, is, the Dijon cold jet, tip jet. We liked the concept. We found it very unique. It had some advantages to it, but we sought limited capability for operational missions. So that was the end of our evaluation of the Dijon. Okay. The Doman H-31. This project purpose was to evaluate the unique Doman rotor system. As you know, you just saw, it was unique. The project was hindered, however, by numerous aircraft deficiencies. It had malfunctions and failures. It was not sufficiently reliable to complete the evaluation that we wanted to do. It was hindered by transient fuselage oscillations in flight and also on the ground. Various malfunctions of the direction control servo and insufficient anti-torque rudder in a hover to stop a rotation. It had a limit on one side. You start turning the other, you couldn't stop it until you got in forward flight. Engines unreliability. We had 2 engine failures, and we had high instrument vibration, and I had to keep holding the door shut because it would vibrate open in flight. So that wasn't considered too good, but that had nothing to do with the rotor system. So we're trying to evaluate the rotor system. We had other things that occurred, and finally, after several tail rotor limitations and the tail rotor shaft failed in flight, we decided to terminate the project and say, evaluate the rotor in the wind tunnel, which we did. Next one, please. This is a McDonnell 120, which was out of the old little Henry and out of their other little converter plane. It had excellent flying qualities and performance. I really like this little thing. There's no vibration to speak of. The cockpit layout and visibility for the pilot, as you can see, was obvious. It was excellent. It was flexible, the flexibility of the fuselage. In the fuselage, they would put different stores in there. They could put cargo in there. It was really designed for firefighting, and it did a good job. The jets created, however, a halo effect. Next slide. And therefore, at night and in the daytime, or twilight, it was noisy, and you get a halo effect of the flame going around your head. So that wasn't too good. 120 dB was the noise outside of the airplane. But other than that, it was an excellent performer. You could carry, its V&E was 105. You could carry 1,000 pounds on a cargo hitch to 100 knots with absolutely no impact on the aircraft. It was very, very good, 1,210 pounds. Really liked it, but because of the noise and the halo effect, it just wasn't operationally feasible. Okay. Next slide, please. This is the HUK. It had a single engine, was 5 places, you know. It was Charlie Command syncropter. And like a coaxial, when you're going into auto rotation, you had a mechanical mixer that would change you from right rudder, it would put in left rudder, obviously for the reasons power on and power off. One thing that we found about that is it was unique at high altitude because there was a dwell zone that I called from down collective to come up a little bit when you're down at sea level. There'd be a point like you do with a coaxial where there's no control at all. But that was in a limited spot. And then you pull the power on, as many of you know, you could get your plenty of directional control. However, when you get to altitude, that dwell zone starts taking up the entire collective position for power. And my first experience on this was at 14,000 feet. And I leveled off because I could get it to 14 that day, lowered the collective a little bit, the nose swung to the left, the bank to the right. I had 70 degrees of yaw, 20 degrees of bank, and I got into a right spiral. And I could not control the aircraft. Tried to control it in pitch, had some control, but very, very little. Finally, after so many turns and getting down to 6,000 feet, we got enough Q over the tail to get a little C and beta back, got it out of it, and it worked. And I found out from talking to Al Newton up at command, who was the chief pilot at that time, what is going on? He said, well, Don, you're supposed to roll into the turn. Now, here you are going down sideways in a spiral like a spin, and you're supposed to roll into it in a chopper. You roll into it, and over 40 degrees, it would kick out. Because you'd go up to 120 degrees of yaw, the tail would be there, and it would kick you around. I didn't think that was too good for operational use, so the seating was limited a little bit, but it was more than satisfactory for the operation that it was designed to do. And that was cargo work down low with the fleet and plane guards. So we went ahead and approved it with some restrictions and limitations. It was also very weak in performance, but the engine outperformed what it was supposed to do, but it had enough to do its job, so that was approved. The next one, please. Now here you see two together. That's me on the left side, and Jim Ryan was a fabulous test pilot for Frank Piasecki before he bailed out at 600 feet in a structural demo. First one to do that. And he's with a Gyrodyne coaxial. I'll talk about that a little bit more. The XROE, you may remember from the commercials in the old days when Dick Peck was flying it for Camels. They would fold it up and unfold it. Dick would get in, start it up, and take off and fly around. It was very limited in weight, 562 pounds, I think it was, max. We couldn't put radios in them because we put instrumentation on it. The problem with both of these aircraft is you couldn't let go of the stick or the collective in flight or at any time. So you couldn't do other things to adjust yourself. The XROE, because of the short coupling of the tail boom, had an extremely difficult tail rotor design problem. Structurally, it was very limited. 10 hours of life. The control itself, once you put in an input, say you put in 1/10 of an inch to the left, within the first 4/10 of a second, you would yaw 90 degrees. And then it would accelerate to the rate where you couldn't keep it up, and then you had a hard time stopping it. It would also then fluctuate. The torque and the rotor RPM would decay terribly if you were to the right or to the left. We finally discontinued it because I was checking out other pilots, trying to see how they were going and what they could do with the aircraft. And the engine quit twice in the hover, and before they hit the ground from hovering in ground effect, they went around 360 and 380 degrees. So we felt this wouldn't be good for the trials they wanted to do in the Marine Corps, so the program was terminated. It was an interesting little one. And the next one, please. Now, what is good about this little bird is it had a Porsche engine. Well, let me tell you what is bad about it at first. You had to pull start a Porsche engine. No electricity on it at all, no battery. We had an instrumentation package on the bottom, but on the tips of the blades, we had flat plates. And instead of using the Delta like they did with the Syncropter and like they do with the Commonoff coaxials, it has a tip rake that would extend either on the lower rotor or the upper rotor, and that gave you your directional control. And it was outstanding. It was a nice bird to fly, except the engine kept wanting to quit, and you couldn't let go of anything because the stick would fall over. The biggest problem that we had was I was flying it in February. The biggest problem I had in one of my flights. And we kept worrying about, was I going to be able to see, whether my glasses fog up and all those other things, and the downdraft would really protect you and do a good job of it. But when you go over into an auto rotation, the first time I did it, the downdraft came up, and my glasses, of course, fogged up, and I couldn't see a thing. So here I am coming into the ramp. I can't see where I'm going. I can't let go of the stick. I can't go of the collective. What do? You wiggle your nose. So you look out of a little spot like a quarter on your glasses, and that was my first auto-rotation landing. But it was quite a bird. It did everything it was supposed to do. It went on to Marine Corps demonstrations, and they evaluated it. One thing they wanted to do was train it for the infantry, and the colonel came down to me once. He said, "Can I train the infantry in this?" I said, "Yes, if you send them to flight school." He says, "Well, then they're not infantry." I said, "That's right." He said, "Well, can you train anybody to fly this?" I said, "If you're patient enough, you can train a monkey to fly, but it's going to take a long time, because this was more difficult to fly." The other thing that was disoriented was when you got up to altitude, about 3,000 or 4,000 feet. You don't have any reference in front of you, and your head was right on the roll axis. So you had no reference on these things. And believe me, that's where handling qualities come in and really disorient you if you're not very careful. One time I had an engine failure. I was about 3,000 feet. I had a chase plane, the HUK, and I'm over the Patuxent River, down in Patuxent River, Maryland. I had three choices. One was the river, and I wasn't about to do that. The other one was a field where they were plowing it 90 degrees to my course. The other one was straight ahead over some trees into a back farmyard. And I said, discretion is the better part of the value. I'm going straight ahead because I know I can't land on those furrows with those little wheels. I came up on the trees. I had to flare it real hard. I hit the bottom of the aircraft on the top of these trees about 80 feet high, pushed over, came out and flared out and landed in the backyard. And here was this lady with her young boy, and I'm in an orange suit with a white helmet on. She threw her laundry up in the air, ran in the house, closed the door, pulled down all the shades, and she thought somebody from Mars came, I guess. But it was quite a sight to see. And the press played a lot with that one. But it was a good bird, and it did its job. It ended up being the Lamps aircraft for the U.S. Navy. They made it a little larger, put torpedoes on it, put a turbine engine on it, flew it remote-controlled off of the back of destroyers. Okay. Now, this is the bird that I consider to be the best reciprocating power helicopter ever built in that time frame. The HUS, as we call it in the Marine Corps, the HSS-1, and here we developed the HSS-1N, working with Sikorsky. It was just a fantastic bird to do what you need to do. We used to go out and manually fly this on instruments under a blue amber and hover it. Then go into the hover and out of the hover. Now, this is before we had the auto throttle, before we had heading hold, and before we had ASE. We developed those one at a time. First, we got the heading hold. Next, we got the auto throttle. Then we got the Doppler in so we could hover over given area space. We developed that on the one end along with Sikorsky. They did the engineering, we did the flying portions and fed back to them. That really made these things into a great ASW aircraft and started developing, as far as I'm concerned, the leading to the HSS-2. It just did everything we wanted it to do. The only thing that we had a problem with was once when I was making a real high-powered climb, again trying to go up the service ceiling, and my collective came up and I went to roll the throttle off and the throttle would not move. It was jammed full open. And of course, when you lower a collective, what happens? It's going to overspeed. So what you do is you slow it down as high as you can, and then you just pull it way up, zoom up on the climb, get it down to 80 knots, at which time I then had the mechanic cut the mixture off. We always flew singly with a mechanic if we could, and cut the mixture and then did an auto rotation from 9,000 feet down the field. And put this out to what was I worried about? I was worried about going 130 knots and then having to cut the throttle there and with a high collective and getting into blade stall. So we put a bulletin out to the fleet that this could happen, and it did. And of course, the squadron commander, it happened to him, but he went to 130 knots, which was over the red line, and he pulled the mixture back and he went into blade stall. But this turned out to be a great airplane for us and for the U.S. Navy and for the Marine Corps, and of course the S-58. The next one. This one was quite a bird. I thought, in all respect to slats back there, I thought the H-21C was one of the worst flying birds I've ever been in, except maybe the Hup. I mean, you want to go to the left, you'd push it to the right, and all those other things. You'd finally figure it all out. And this is the H-21D. They changed the transmission, well, they changed the rotor blades, the mass distribution on them. They changed several things in the aircraft. They put the turbine engines. They limited the two T-58s. And this was the first twin turbine evaluation we had. We had one in an HSS-1, but it was a single engine. It made all the difference in the world in that airplane. They put a SAS system in it. For some reason, the vibration went away. And with the SAS system, it flew like a jewel. But we had to stop at 140 knots VNE because of the windshield flex. So that was the only reason. It could have probably gone another 10 or 15 knots if it weren't for that. But with the new rotor blades, the T-58s, it was great. What did we learn from that? Quite a few things. One is that SAS will really help. We found a little bit of that in the HSS-1N. Two, we learned about transient droop and permanent droop of the T-58 engine. And we plotted those, and GE was able to work with that, funded by the Navy, I'm sure, or somebody, and came up with a new revised 3D cam at those days because it was mechanical, and got rid of most of that droop characteristics. So that's what got us on to the way we have all of our droop characteristics compensated for now in our new electronic controls. So it turned out to be a great little bird. Okay, the next one, please. That led to us flying this. This is one that was given to, a contract that was given to Rotorcraft, I am told, as an intermediate way to keep them moving while they were doing the Chinook. It is the YHC-1A. We evaluated it just for a couple flights. We brought more pilots up to fly it, including some of our very senior ones. And it turned out probably to be the most outstanding helicopter of that period that we had ever flown. In fact, in our report, we said it was, well, once before anything else, I'll say that it had an excellent cockpit. They listened to their test pilots, Leonard Levasseur and the others. That aircraft was designed for a pilot to get in and fly alone if they needed to do it. I can't say that for some of our other manufacturers. It had really close input. The final naval report said this aircraft was, quote, found to be capable of most of the missions, needs, and requirements of the Navy and the Marine Corps in the future. Major problems such as high vibration at high speeds were asserted, no, I'm sorry, I'm jumping ahead of my, this was considered to be the outstanding advancement in helicopter design of that period. It went on to be the H-46, but the Marine Corps changed everything so much on it, it wasn't the same bird. So they had to work out those problems. Okay. This is another very unique aircraft, the HSS-2 with the first 258s. It, fully articulated, as you know, automatic blade folding came in for the first time. It was scheduled at first to go to 165 knots, but the vibration became pretty heavy out there. In fact, so heavy that the instruments would jump up and down, and my co-pilot would get ill once in a while. So we finally limited it back to 140 knots. And Sikorsky began working on the vibration problems. There was also some high vibration in the tail and some tail kick. But all those things were finally worked out. And with the automatic stabilization equipment, the capability of hovering in and out of a hover on IFR took some time, but we got there. And as you know, it's still flying today as Marine Corps One and flies the President around. The thing was not amphibious. As you can ask Stan Caple, who was the GE test pilot. He lost one engine down on the Key West, put it in the water, tried to taxi in, he called for help. And the tower and the crew down there at Key West said, well, you're amphibious, just come on up the sea ramp. Of course, by that time, he was ran out of power and the aircraft rolled over and sank. Because it is not amphibious, as we all know. Okay, next one. The VTOL 76. Now here we get into the flights that we conducted. I was first one asked from the Marine Corps and the Naval Aviation to go down there. I wanted to show the pilots because they're very unique. On the right is my engineer, Webb Taylor, who was with NATC. The next pilot is now passed away, Jim Reichert, who was a designer and the test pilot on Dokes, which is a VZ-4 on the right. Then you see Jack Reeder, who is the great NASA pilot. We did a lot of work together, an awful lot of work in simulators, Mercury, VTOL, and everything else, and Jack was down at Langley. Another one's a good friend of mine, Fred Drinkwater, who and I went to the Marine Corps together, and he was a test pilot out of Ames that did so much for VTOL. And Jim Whitten, who was a number 2 pilot to Jack Reeder, and I believe the fellow on the end was an engineer from VTOL. It was quite a unique aircraft. We could do a lot with it. I had a 20-flight program on it after they left. Why we're all together is that Jack Reeder and Leonard Levasseur had been the only 2 flying it before then. So the 3 of us all checked out in one day, and then I stayed down there for 2 weeks and went on with another test program. We learned an awful lot of things from that aircraft. It only weighed 3,400 pounds. It only had about 35 minutes of endurance. The wing area was only 110 feet. The envelope tested went from -5 to 110 knots in forward flight. We had an ejection seat that Jack had put in it, which was very nice, but you can only use it 300 feet above and about 80 knots and above. But that was better than nothing. Some of the things we learned on that, and NASA started making improvements on it, really turned out. It was finally flown by 28 different pilots. Now, one thing that people don't realize about this aircraft is that it had an automatic transmission from a Dodge car that coupled the drive systems. No mechanical coupling. It was all done by the transmission, the fluid transmission. But anyway, these pilots, I felt, contributed an awful lot. The Doak, of course, went on to do things. The problem with the Doak was it was very noisy. My concerns were at that time, this evaluation was to let the Marine Corps know, what are we going to do in the future? My concerns were, how are you going to bring it aboard ship with that big wing up? How are you going to fold it to get it down below deck? When you get the wings down, how are you going to fire any stores off of it forward? Or with guns to rotate? They'll all have to be fuselage in line. All of those kinds of questions came up, and the Marine Corps considered it. That's one of the reasons I think they went more towards the P-1127 and the Harrier. And incidentally, the United States contributed $38 million to the early development of the P-1127 in that period of time. And it turned out to be a good airplane, took a lot of work, and some of my good friends flew it. Okay? So that's to give you a little bit of what went on. I'm not supposed to talk about anything past 1961 and my time there, and that was just a little bit of what we did. But I thought you'd take a look at this one here, because that's a picture of me and the bird. It's sunrise down in Arizona. I'm at 22,500 pounds, 8,000 feet, and I'm cruising at 200 knots. That wasn't too bad. It's the only airplane that I know of that has velocity damping. It's the only airplane I know that can go compound with all the stuff not coming down in front of the wings so you can fire stores or out to the sides and the right. It's the only airplane I know of that was totally IFR capable without any SAS. No electronics to help you with your pilot controls. It's the only airplane I know of where you could take your hands off of any speed. You could come in, if you wanted to hover, set your trim tabs, let it go, it would go into a hover and sit there. It met all the mil specs, and it answered all of the issues except one. How do you beat the politics? Thank you, gentlemen. I hope that helps.
Thank you, Dan. Not yet, just a minute. Several of us here have got fond memories of the Cheyenne. We got half an hour almost before lunch. What I want to do is get a couple of our overseas people in right now. Basil Arkell, who flew autogyros and R4s in England right at the beginning of a helicopter. And then we're going to have Jean Bollet, who's got a schedule problem this afternoon. And if we get past those, then Miller Walks will be the next on. So, Basil, are you ready?
Where would you like me to go? Over here?
Oh, 3 parts. Oh, all right. I can. Okay. Yes, you're ready.
Okay. Good morning, ladies and gentlemen. I'm afraid I haven't any advanced technology to talk to you about. I haven't any sophisticated films, but I thought you might like to hear one or two anecdotes of the very elementary state of the art that we had to contend with when we first started flying at Floyd Bennett Field with they put in an order for Sikorsky R5s, and the R5 was the predecessor of the S-51. It had the pilot sat in the rear seat, and the observer, watching for any signs of submarine periscopes and that sort of thing, would be up in the bubble in the front. With the R5s, or with the prospect of the R5s, they also ordered 5 R4s. And they put in about 6 or 7 Navy pilots to learn to fly these R4s with the eventual prospect of taking the R5s out. And at that time, I was flying with the 529 Squadron in the RAF on autogyros. And the Air Ministry, I think, didn't want the Navy to have their toes into the rotating wing field without finding out what was going on. And so they sent 3 or 4 RAF pilots from 529 Squadron, the autogyro pilots, to Floyd Bennett Field to develop the R4 with the Navy pilots. And we were flying around there, doing local flying, getting used to the handling characteristics. We had all been fixed-wing pilots, of course, and we had to get used to the different handling characteristics of the rotating wing aircraft. We've heard a very interesting talk from Sergei Sikorsky about his developments, his father's developments with the VS-300, and shortly after the success of that, it was, I think he was saying, in about 1942, the first R4 was tested. It was an XR4. We had at Floyd Bennett Field YR4s to start with. The US Coast Guard were interested in them for general reconnaissance purposes, and the Navy, the British Navy's 5 R4s, were located at Floyd Bennett Field alongside the US Coast Guard machine. So there were about 9 helicopters there in the hangar. And one of the things that in those days, these machines were full of vibrations. They all emanated from the rotor, and there were no hydraulic controls, no electronics. Anything that was happening in the rotor was coming straight back to the pilot's cyclic pitch stick, his control stick. And we used to reckon if we got the aircraft out of the hangar in the morning, we used to reckon that if the top of the stick was not describing a circle of greater than about 2 or 3 inches radius, that machine was more or less all right to fly. They were very, very lumpy. But we developed methods of smoothing out the rotors. The blades were steel spars with wooden ribs and covered in fabric. And it was not, no 2 blades were exactly the same. And when you sat in the cockpit and you could see the tip path plane up ahead of you, you could see that the blades were all following different tracks. And so we had to find methods of tracking the blades. And the first system we used was very elementary. It was a long pole with a paintbrush tied to the end of it, and the brush was dipped in a can of creosote, sort of light tarry paint, and the system was that you engaged the clutch, got the rotor running at approximately 5 degrees pitch, pulled it up a little bit, and at about 1500 engine revs, which gave us about 150 rotor revs. And then 2 men would very carefully raise the pole up until it was under the rotor, and the brush touched the lowest blade. And when they'd got a touch, you had to stop shut the engine down and stop everything. And then an adjustment was made to the angle of incidence on the rotor head of the lowest blade to bring it up to the next one. and then you do it again. And so gradually we were raising the incidence of the blades one by one until we got a fairly reasonable tip path plane, and the vibration was reduced. And probably an average, when we finished the tracking, we'd get the vibration on the top of the stick down to about an inch diameter circle, and that was, we reckoned, was fair enough. Now, we had rather an amusing incident following on from that. On the Sikorsky R4, there was a pitch indicator which was a small tube which stuck up from the instrument panel, and there was a pointer in it. As you raised the collective pitch lever, the pointer raised up and indicated from 0 up to a maximum of, I believe it was 10 degrees. We used to train the fitters to warm up the engines in the early morning, ready for a flight program. And on one occasion, we had one sergeant fitter. His name was Culver, and he was a Scotsman with red hair, and he was always known as Ginger Culver. And he started up the engine, let the clutch in, and raised the collective pitch up to an indicated 5 degrees, and ran the engine at about 1,500 revs to warm up the motor. After about 10 minutes, when he got up to the operating temperature, I forget exactly what that was. It was probably about 200 centigrade. But anyway, when he got ready to test the magnetos, he opened up to full revs, which would have been 2,000 revs, with the throttle. And of course, as I have explained, the stick would be, he would be holding both sticks. But what he didn't realize was that that particular machine had been tracked on several previous days, and there was a lot more actual incidence on the blades themselves than was indicated on the indicator. And so when he had 5 degrees indicated, he had about 7 degrees, or possibly even a little more, on the blades themselves. So when he opened up to 2,000 RPM to test the mags, he took off. And there was never more surprise to Sergeant Fitter in his life. Fortunately, he was only about a foot up, and he didn't lose his head, and he slapped it back down on the ground again without breaking anything. But it was a good story, but that was the sort of thing we had to contend with. Eventually, the tracking was improved by using a flag and chalking the tips of the blades with different colored chalks. A canvas flag on a long pole would be turned into the tip of the blades, and then you would have 3 colored chalk marks on the flag. So we went on. We flew several hundred hours there at Floyd Bennett Field, and eventually we brought 5 aircraft back, the 5 R4s back, on an aircraft carrier in a convoy, and we set up a school at Andover in England to train Army cooperation pilots, because by that time the anti-submarine control had been solved, and the Navy cancelled the order for R5s, and that was the time when it was eventually developed into the S-51. Now, I don't know how much more time there is. One other amusing incident that I had was that the US Navy wanted to try calibrating their gun sight weapon systems with a helicopter, and so there was cooperation from the US Coast Guard, and they did some modifications to one of the R4s. They fitted reflective aerials onto it, and fitted an RT set in it, and they suggested that I should go and do it because I'd done I was used to radar calibration from the autogyros. So off I went. This destroyer was anchored just down south of New York. It must have been a little bit down southeast of Staten Island. And so off we went. I took a chief, I think it was a chief petty officer from the Coast Guard with me to operate the radio, because obviously, as one of the other speakers said, you couldn't let go of the 2 sticks, collective and cyclic sticks, to operate a radio at that time. So anyway, we found this destroyer, and the first problem we had was that this chief petty officer turned to me, Miller his name was, he turned to me and said, I can't get the radio to work, I can't raise them. And he said, can you go and hover alongside the bridge and I'll see if I can contact them. So I expect you've probably seen pictures of an R4. You have a sliding window. So anyway, I went and hovered alongside this destroyer's bridge. And this chief petty officer was, he opened the window down on his side and he hung out of the window and he was waving his arms about like this and semaphoring to the signaller on the bridge. And I was hovering at about 30 feet alongside the bridge wings, and normally the R4 wouldn't hover out of ground effect, but there was a little bit of breeze out there, and so really it was, I was flying forward but not moving at about 10 knots, something like that. But anyway, he turned round to me after a bit of arm waving and said, they want you to hover at 5,000 feet. And I said, what? We had been doing local flying around Floyd Bennett Field, and none of us, even for autorotation practice, we'd never been much over 1,000 or 1,500 feet. And this was fairly, I thought, impossible. But anyway, we clambered up to 5,000 feet, and I managed to stay there for a while. But the first thing that happened was that we found we were in the circuit for LaGuardia. This was 1944, and we must have been in the circuit for LaGuardia airfield, and we were being swooped past by civil airliners in round about the size of Dakotas. And I think they were all having a good look and wondering what the dickens we were doing there. Anyway, we did manage to do it. And I've got in my logbook, the flight was, by the time I got back, it was 1 hour 50. But both my hands were sort of very numb by the time I got back on the ground. But at least it worked. I don't know, we never knew what the Navy did with their experiments, but as far as we're concerned, we got away with that without breaking anything. Anyway, someday I shall be here for this afternoon, and if anyone would like any more to ask any questions about the autogyros, we were using those for radar calibration, and I'd be only pleased to answer any questions. Thank you very much.
Ray, can I make a 2-minute comment on his tracking problem?
Sure. Make 2 minutes and we'll break for lunch.
Oysters. Sympathy to you
Yes?
in your efforts to track the FlyR4.
Yes?
I was working on that stuff at the plant, trying to get the train gauge ship to be flyable over the envelope.
Yes?
Can you hear me?
Why don't you come up here, good?
All right.
You all right?
I need a hand. Old age.
Okay. How did
Sympathy to you. Struggling with those problems at Sikorsky, I can vouch for the fact that he could absolutely not get a smooth stick without a 1 per rev in the fuselage, or vice versa. Rarely a set of blades came together that would fly in formation, but that was rare. We were too neophytish to understand that the pitching moments on the blades due to camber were the cause of the problem. The ships absolutely could not be tracked with pitch. We woke up to the fact that we had to adjust the trailing edges, not only somewhere, but suitably outboard or inboard, up, down, blah, blah. So he learned how to trim the blades pitching moment-wise, which came as a benefit to the R4s, which flew much more decently.
Very good.
Our regrets to what we subjected you to.
Okay, I was told that the lunch break is at 12 o'clock, which is in 2 minutes according to my watch. So let's break. After the lunch break, we're going to have several of these corporate presentations, and then we'll get back to the individual ones. So try to be back here by 1 o'clock, please. It's early days at Command. Charlie Command is not in very good health, so he sent Mike Bowes to make this presentation. Mike?
Thank you, Ray. I won't be making a presentation. I'll make a few comments. And I brought along a tape that we put together that really Charlie did a couple of years ago, and it goes through the development of our first helicopter, the K-125. And it really is, from the engineering perspective, those of you, and I see a lot of faces here that spent a lot of time working in that era. The era we're talking about is 45, 46, 47, 48, that time frame, when Charlie got into the helicopter business. And he really does a good job and narrates the tape, and I think it does explain his ideas, the servo flap rotor that he brought to the table to do two things. One, to solve the control loads problem that we talked a little bit about this morning. It also provided a way to solve the blade tracking problem. It continues to do that today. So command helicopters don't have blade tracking problems. I'll mention Charlie's health. Charlie is his health is a little bit degraded. His mobility is not as good as it used to be. He's still active, and until the last couple of years, really the last year, he was active as an engineer in command. I'm in the engineering department, and I can assure you that he was the chief engineer of Command Aerospace Corporation until about a year ago, and he had played a very, very active day-to-day role in developing the new composite main rotor that we use on our H2 today. And it was on a daily basis at the world stand, looking at the oscillograph rolls, or the computer equivalent of that today. So without any further words from me, if we could roll the tape.
SH-2G helicopters ready for delivery to the Navy, it's a good time to reminisce on the beginning of it all, the original vision, the saga of the K-125, the first helicopter built by then Command Aircraft Corporation. Here's the story. The dream of 1945-46 was that the Command K-125 would be a helicopter that could be flown by anyone, everywhere, and would really darken the skies. Two people in the back, one in the front. The work began on the test tray to prove the rotor, incorporating our aerodynamic servo flaps, would work. Long hours were spent there, and eventually we built the first airframe, K-125. We took it out for its earliest flights in January of 1947. Bitter cold, we were to encounter our first major disappointment. The clutch would not engage. It seemed that the delicate balance between the spring rate and the shoes of the clutch to engage the rotor was just wrong. And as it would come up to speed, it would start chattering, sending enormous torsional vibrations into the blades, and how they held together and didn't break under that punishment was really very surprising. We tried and tried. Finally, on January the 15th, we made two changes in the blizzardy, cold, rain, sleet. Oh, it was bad weather. We had to fly on that day because that was the day the $36,000 provided us by New Enterprises would be gone. And that was to have a first flight. These films show it in the late afternoon of that day. And we almost made flight here, but not quite. Flight occurred 6 inches off the ground against the ropes at dusk, when no longer was there enough light to have a record of it. But we do have a record in the minds of all the people that were there, emblazoned forever. The crew had worked very, very hard. Long hours were almost a starting point. The bitter cold was something you took for granted. But it flew. And it really was a great, great emotional release when that occurred. A few days later, we went outside with Eddie gone on a Sunday morning, pulling down on the tail of the bird every time it would get off the ground. The whole crew were there. We didn't have hard hats or any protective measures. What we would do if something went wrong was not even a consideration. It was not expected, and it did not occur. The first flights in this way, and what followed a few days later, as the snow began to ease off, was the first realization, having fixed the clutch, that our control sensitivity was too great. You see here, when it took off, the pilot was immediately over-controlling. The ship was bouncing around. That was resolved by changing the ratio of the control from the pilot stick to the servo flaps. Meantime, the rotor had been designed to be a single degree of freedom teeter, like a seesaw. But in the presence of a large coning angle, which means a lot of lift, that can give rise to very serious Coriolis forces, which come from acceleration in the plane of rotation. We didn't expect to have coning angles so high, but it didn't appear that they were going to get any less with the configuration that we had. So we resolved to put in a lead lag hinge to relieve the Coriolis forces. That also necessitated a lead lag damper, and that was made by a couple of tubes with brazing brass in between as a friction device. All of this was done in a matter of days, a week or two at the most. And in the resolution of all of this, we were solving major, major problems. We didn't know it then. There was no textbook. There was no guidance. And furthermore, nobody in the world had ever flown a servo-controlled rotor of this configuration. Meanwhile, I had selected an intermeshing configuration in order to save the power that's otherwise wasted in the tail rotor. So even that was new. Although it had been done in Germany during the war, we didn't have access to any of the German data, and we really didn't know what we were getting into until we got there. Flights continued little by little, improvements day by day. And finally, we were ready to venture into a little bit of forward flight as well as hovering. These were very exciting days, and that's the ramp out there by the revetment at Bradley Field, still showing those devices built during the war, World War II, for protection of Bradley Field. The bird was much more stable now. It was really showing its potential as we eased it into forward flight, and suddenly, in addition to hovering, we were flying. Flying with great success. It was clear now that we had the solution. Everyone was thrilled and happy. Watch Schuler dance in the background there. Very good. After all the effort and the painstaking night and day, suddenly we had reached the point where Jack Rohr, our pilot, was beginning to practice for the big demonstration for new enterprises that was scheduled for Good Friday. Well, in effect, he had to learn to fly this plane. It was unlike any other, and would learn with time, much more forgiving, more docile, more stable. But the control forces just moving the little servo flap were almost negligible. And it was virtually fingertip control, unheard of at the hour, at the day, at the time. Other helicopters changed their rotor blade pitch at the root and had a horn attached to the control from the pilot that moved the blades. Pilots would virtually get muscle spasms after an hour or so. They were enormously difficult to fly. And those forces were very, very great, to be resolved years later with hydraulic servo. But here the Command K-125 was flying with an aerodynamic servo flap, and it had virtually minimal control forces. No one had ever flown such a plane before. And hence it was necessary for Jack to learn how to fly, which is what he was doing in all of these sequences. In and out of ground effect, sideways, turning, forward, backwards, all of the maneuvers a helicopter is expected to do. When the great day came, myself, Jack Rohr, of course Bill Murray was there, Marty Stevens, there were many others. And this was the flyby on Good Friday that got underneath Gene Hotchkiss to the extent that he had to slap me on the back right there. Success was very delicious. So now everyone said, well, of course, you've flown your principles here, you've demonstrated that, but let's finish the bird. Why don't we make it into a helicopter that you can raise money with? So we went on with this, finishing the bird by degrees. Unfortunately, in our haste to get it done, we abandoned the need and the cost of making tools to make aluminum forms and bulkheads and to have the proper lightweight skin. We made it out of 3/8 of an inch plywood for the bulkheads, and we covered it with plywood also, maybe a 1/16 of an inch, an 1/8 of an inch, that kind. This tended to increase the weight, and that was bad. The weight went way up, much too fast. And by the time we got around to finishing the bird and roll it out as a sparkling red flaming machine, it was pretty badly overweight. So much so that when we flew it in this configuration, we knew that the 125 horsepower, 4-cylinder engine was not sufficient to do the job. We did prove a lot of things with this. This was about the closest we would get to that original artist version that was shown at the beginning of this film. Having got the rotors tracking, Bill proceeded with the flying, but alas, it was quite clear now that we were simply underpowered. So we took the tail boom off, we took the engine, and we took it out and put in a 6-cylinder Lycoming of 185 horsepower, and suddenly we had enough power. These flights were made to check the drive system. That's why the tail hadn't been added right away. And the drive system was, after all, exhibiting the most singular advantage of the intermeshing helicopter: simplicity. The engine drove directly into the gearbox, a single gearbox which drove the shafts, which turned the rotors. That principle is even more vivid in its value today than in these early years when the concepts were laid down. Simplicity and reliability cannot be overrated. And the absence of the tail rotor and all of the intermediate gearboxes and the tail rotor components and so on was really an early revelation of how much more efficient would be the intermeshing configuration. It was proven right here in 1947 and in 1948. But we learned something else at that time. The CAB, Civil Aeronautics Board, issued new regulations that would be impossible to fulfill with our meager capital resources. We would have to abandon the concept of the K-125. And in its place would come a special helicopter, a special agricultural plane for dusting, spraying, fogging, and whatever. Because in this manner, the new K-190 would be within our means to certificate with the then CAA under the new CAB rules. So as these flights were winding down, we knew that the K-125 had done its bit. It had proven our principles, and we were very grateful for all that we had learned and the marvelous safety that had been achieved with this early plane. We did go further. We put a single large fin on it, and I undertook to fly. The comic relief of the captions of the day notwithstanding, it was great fun. I didn't even have a pilot's license. I took my hand off the controls to wave. And then, of course, maneuvering, turning, all the rest. It was just great fun. The covering around the nose section had been removed at the time, but it was restored a little later on. And then we had the K-125 and the K-190 flying together. And as the K-125 was winding down its purpose and use, the K-190 would come in and take over. Bill was flying the 190 and I was flying the K-125. We had a fleet of helicopters. By the way, that building back there was the gymnasium, which was our home, 10,000 square feet at Bradley Field. The K-190, K-225 series aircraft became the cornerstone of Command Aircraft's entry into the helicopter industry. Both were certified by the then CAA, today FAA. But the K-125 had a few other tricks up its sleeve. We participated in a movie that was locally done, and we dolled it up again, put on the front frames, painted it up, so that it could participate in that filming. We went on from there to actually put more fins on the back end, as originally contemplated, to explore stability and control, and it's shown here in that configuration. I was flying it again, and this is sort of the wind-up before its final retirement. So looking back, we had a concept, we had a dream, we had an ambition. And we proceeded to try to make it happen. Life can be cruel for reasons beyond our control, the CAV. That was not attainable. We had to divert our energies in other directions. But the triumph of success does not go away. And the success that is achieved through extreme efforts is with you for the rest of your life. The confidence that this early work gave us in ourselves in the absence of any precedent whatsoever that we could call upon was truly one of the greatest confidence builders one could ever expect. It was a joy, it was a privilege, it was an extreme exertion to show what man can do. It meant the safety of the company, it meant the safety of all the people, it meant Command Aircraft would go forward in its role in helicopters in the United States. And with a heroic start, such as the K-125, indeed, Command did go forward and play a role in the development of the helicopter industry in America. We built helicopters for the Marines, the Navy, the Air Force, the Navy again, and played a principal role in the development of technology in rotary wing aircraft. Today, after nearly 50 years, we are able to call on that technology to take us into the 21st century with a new vision.
The doors open at dawn, and as they step into the morning light, these test pilots know they're a breed apart, and so is their aircraft. They know they are the best in the world at what they do, and they have the confidence their aircraft will perform that same way. Here at Command, we build helicopters for them.
Mike said that's
the last scout, Charlie, in addition to being an engineer and a businessman, is a salesman, and the last part of the tape is a little bit salesy, so we can cut it off. If anybody wants to see it, we could perhaps show it later. But thanks for your attention.
a disc up here in the machine. Are you going to make the presentation?
Good afternoon. Мое имя Сергей Михеев. Я президент фирмы «Камов», российской фирмы «Камов». И нахожусь на своем посту с 1973 года, практически сразу же после смерти Николая Ильича Камова.
My name is Sergei Mikheyev. I am the head of a Russian helicopter company, Kamov Company. I took this position in 1973, right after Nikolai Kamov passed away.
В этом году исполняется 100 лет со дня рождения Николая Камова, безусловно, выдающегося человека, который всю свою жизнь был увлечен идеей полета с использованием ротора, несущего винта.
This year we will be celebrating the centennial anniversary of Nikolai Kamov, a really outstanding personality who devoted all his life to the idea of a rotorcraft, an aircraft with a rotor.
Это был инженер, который оставил в памяти потомков свое имя как создатель реального серийного вертолета соосной схемы, идея которого уже известна более 250 лет.
Nikolai Kamov was an engineer whose name remained in the aviation history as the name of the designer who brought to life a real large-scale coaxial helicopter, which idea was known for more than 250 years.
Свою деятельность Николай Камов начал в 1929 году с создания автожира. Здесь на верхнем фото слева помещен, показан, сфотографирован он сам и его помощники, пилоты и механики.
Kamov started his engineering career in 1929 by designing an autogyro. On this picture, on the upper picture to the left, you see Kamov himself and with his assistants, a pilot and a mechanic.
10 лет были отданы созданию автожиров, различных конструкций, но главным за этот период надо считать практическую работу над конструкцией лопасти ротора с остальным несущим лонжероном.
10 years Kamov devoted to autogyres of various configurations, but his main activity during this period was a practical work on designing a rotor blade structure with a steel tubular spar.
В конце 30-х годов завершен полный цикл испытаний и рекомендован серийное производство автожир А7, который имел как военное, так и гражданское назначение.
At the end of the 30s, A7 autogyre has completed a full cycle of tests and was recommended for serious production as a military and civil operations.
Сейчас в том месте, где находится главный офис фирмы, в 1940 году правительство Советского Союза принимает решение на одном из подмосковных аэродромов делать завод винтокрылых летательных аппаратов.
In 1940, the government of the Soviet Union took a decision to establish a first Rotorcraft production plant. It was located on the airfield where now the headquarters of Kamov company are.
Директором завода был назначен Камов, главным инженером Михаил Миль, выдающийся руководитель одного из самостоятельных конструкторских бюро в дальнейшем.
Kamov was appointed the director of the plant, and Mikhail Mil was appointed chief engineer. Later, this outstanding designer became the leader of another standalone helicopter company.
В послевоенные годы, в тяжелые годы нашей страны, Камов строит небольшой вертолет Камов-8 с двигателем от немецкого мотоцикла «Харлей» и демонстрирует его на воздушном параде 1948 года перед правительством и перед Сталиным.
After the war, the period which was very hard for our country, Kamov built the first light helicopter Kamov or Ki-8, which was demonstrated during the air parade in 1948 in front of Stalin.
Эта демонстрация первого вертолета соосной схемы фирмы Камова и стала поводом для создания нового конструкторского бюро в 1949 году.
This successful demonstration laid the basis for establishing a design bureau for coaxial helicopters in 1949.
Демонстрация этого вертолета на параде произвела большое впечатление на представителей командования военно-морского флота. На базе первенца К-8 «Иркутянин» был создан одноместный вертолет К-10, совершивший первую посадку на палубу крейсера «Максим Горький» 7 декабря 1950 года.
Все, следующий. Одним из выдающихся достижений Николая Ильича Камова было создание комбинированного летательного аппарата, сочетающего в себе достоинства вертолета и самолета.
One of the greatest achievements of Kamov was the development of a compound aircraft combining the advantages of a helicopter and a fixed-wing aircraft.
Камов дал ему новое название такому типу летательного аппарата «винтокрыл».
Kamov gave a new name, a new term to this type of aircraft, VTOL.
Эта конструкция во многом опередила свое время.
In many ways, this design was ahead of its time.
Достаточно сказать, что взлетный вес этого летательного аппарата был 36 тонн.
It's enough to mention that the takeoff weight of this aircraft was 36 tons.
Полезная нагрузка 5 тонн.
Payload 5 tons.
Скорость полета, показанная в 1962 году, 360 км в час.
And flight speed achieved in 1962, 360 km per hour.
Впервые были отработаны агрегаты, которые подвергались исключительным нагрузкам.
For the first time, the elements, the components which had the most load-carrying components were tested.
Новая система управления
A new control system
и так далее.
and others.
Однако многие материалы, которые располагал конструктор, конечно, не предполагались нести те нагрузки, с которыми пришлось столкнуться.
But many structural materials which were at the disposal of a designer were not intended for carrying such high loads.
Удивительно, но лопасть диаметром 22 метра была изготовлена из древесины.
It's surprising, but the blade with a diameter of 20 meters was made of wood.
И в отдельных режимах полета скорость на конце лопасти достигала 1 маха.
And on some regimes, the tip speed reached 1 Mach.
Николай Камов умер в ноябре 1973 года.
Nikolai Kamov died in November 1973.
А в июне 1973 года
And in July of the same year,
на аэр-шоу в Париже
during the aviation show in Paris,
была сделана вот эта фотография.
this photo was taken.
На фоне вертолета К-26 вы видите молодого Сергея Сикорского.
Near Kamov's Ka-26 helicopter, you can see young Sergei Sikorsky
И молодого Сергея Михеева.
and the young Sergei Mikheyev.
Из этого исторического документа видно, что прическа а-ля Сикорский была у него еще 30 лет назад.
And this historic document shows that this headdress a la Sikorsky he had even 30 years ago.
Почти 30 лет нет с нами Николая Камова.
Nearly 30 years have passed since Nikolai Kamov passed away.
Но дело его живет,
But his ideas continue to live,
и люди его коллектива продолжают нести обществу и всей цивилизации все новые и новые идеи, новые машины.
and the people of his team continue to bring new ideas and continue to design new helicopters for the world community and civilization.
Следующий. Следующий. Thank you very much. И в завершении от коллектива наших участников этого 58-го форума Американского вертолетного общества я хотел бы преподнести офису вертолетного общества
вот эти две книги «История фирмы Камов за 50 лет».
And in conclusion, on behalf of Kamov delegation here at the 58th Forum of the American Helicopter Society, I want to present two books to the Office of the American Helicopter Society, two books which contain the history, the 50-year history of Kamov Company.
Спасибо.
Очень спасибо. That's my Russian. These go into the AHS library, which those of you who have visited the headquarters in Alexandria maybe know that there is a library in the basement, but it needs some attention. These, I hope, will get filed in the right place. In order to keep things going at the right speed here, I want to ask Miller Wachs to do his presentation at this point. Miller? And after this, we'll have the mill presentation.
The helicopter bug attacked me before there was any such thing as a flying vehicle, as a successful helicopter. It was during my junior year getting a BS in physics that the bug hit. That was in 1934 and 32 and 3. After the bug hit, I more or less followed Sikorsky as a young man in thinking of terms of the configuration of coaxial two rotors rotating in opposite direction, thus solving the anti-torque problem. And made some models and made some tests with it. During my I decided that if I was going to really play a part in bringing helicopters into being, that I should go on with a master's degree at MIT, which involved first getting the basic undergraduate engineering type courses first, so it took a space of 2 years to do it. In thinking of the helicopter, independently of the basic invention that was made quite some years ago, as revealed in the Very Flight magazine, the azimuth control principle. It was original with us, my father and myself, as being the way to conquer most historical attempts at helicopters showed that the control of the helicopter and making it go where you want to go was a difficult problem. And it seemed to me that this azimuth control idea would be the way to go. During my second year at MIT, one of our engineers that was graduating that same year fortunately had a car, and there was 2 aero companies operating in Buffalo at that time, and the 3 of us went there applying for jobs at graduation time. About May, sometime in May, Curtis Wright Company in Buffalo tempted me to come work in the shop first before graduating to working in the engineering department. And in those deep depression years of 1935, it was a great temptation to give up the idea of completing the degree and taking the proposition by Curtis Wright. And it took a bit of courage to grit my teeth and say, no, I got to finish the job I'm doing right now. Incidentally, Igor Sikorsky came to our small aero group at MIT and gave a lecture, and he was looking forward to building even bigger flying boats than had been exploring all the routes in the Caribbean, South America, and even as far away as Australia and China. The point of it was that I had to continue to, and in the process of graduating, I did apply to Sikorsky because I knew as a young man that he had made an attempt at helicopters. And in those deep depression days, there was no reply to that request. I did something that I say even was pretty smart. I thought that maybe the engineering going into the controllable pitch propellers that were being of three types at that time would be the engineering aspects that could be applied to a helicopter. And so I wrote to all three of these companies and asked them if they had any cutaway of their device or any papers they had issued and so on, and they gave me some data. And I wrote my own course of applying the engineering aspects of designing controlled pitch propellers and asked them for any things that I might be able to put in the appendix of this paper, and made enough copies to send to all three of these companies. And somehow, I don't know where it came from, I had a quiet confidence at graduation time that things would work out. But just before that, during the week between the last exams and the actual graduation, I decided to make a dash trip by bus down to Philadelphia, which was the rotary wing capital in America at that time, with about 4 companies. And I made myself known to them and made applications to all of them, and none of the 4 had an offer of job, except that one of the fellows said, first of all, become a good draftsman, but not too good. And that was good advice. So here I was, graduated, and fortunately one of those 3 companies offered me a job at Lycoming Motors, which is associated with, and they did a nice job for us in the fact that I thought anybody designing gadgets that pilots had to go off with some risk to their life and do the experimental flying, I thought that a person should have the feel or understand the feel of pilots that do this. And Lycoming wanted to get into the light plane engine business, and they decided after they certified their engine and everything that they'd conduct a sales tour of the whole United States with 3 models of light planes installed with the Lycoming engines. And when they had completed this tour, they decided to sell 2 of those planes, but kept 1 and made it available to employees to learn to fly. And I responded to that because all we had to pay was for gasoline and oil and the instructor. And the company hangared the airplane, kept the engines, of course, in high tune, And so after that was after we got certified, and at that time you had to demonstrate that you could stall the plane into a spin and get out of that spin. You had, in getting your certificate, that was a requirement at the time. And the only time was that one time that I actually did this to demonstrate to FAA that I could do it, get it out of the spin. Anyway, here I was, eager to make the helicopter happen, and no job. But one of these three companies responded and hired me for 5.5 years at Lycoming. Incidentally, doing that, maybe I mentioned that I applied to Sikorsky because I knew that as a young man he had tried helicopters and thought he might go back to that idea. And Sikorsky had no job at that time. And then about 3 years later, the advanced work on the VS-300 was coming to light in the Aero magazines, and I needed to go up and see my sister married in Boston, and on the way I could stop in Stratford, and so I applied again the second time. Well, by that time I was in a family way with one daughter, and I left the wife and daughter out in the parking lot, reported for this interview. And I read all the magazines in the waiting room, and then finally went back, and the receptionist got all flustered because she hadn't taken care of me yet. Well, soon a man came down, and I said, I'm not the least bit interested in Frozen Wing, which was pouring out of the new factory where United Aircraft had shoved Chance Vought out of Hartford into Stratford, and it was called Vought-Sikorsky. And this man's reaction was, we don't know whether it's going to ever mount to anything, and there's only a very few people working on this helicopter. So, well, that's the way the cookie crumbles, and I said, glad to meet you, goodbye. And then somebody else came down. At that time, it was called Vought-Sikorsky. And another man came down, one of the glue refs, and I said, well, I'm glad to meet you, and I've had my interview, goodbye. Well, I was telling a former colleague of mine that worked at Lycoming, he says, oh, yes, that was a marriage that was never consummated, Vought-Sikorsky. There was two companies in the same plant, and they hardly spoke to each other, actually. So I must have been talking to a Vought guy because he had absolutely no prospect of helicopters ever coming into existence. And so that was the second interview. Third interview was, third application was right after Pearl Harbor. And by that time I owned 1/6 of this light plane, had to leave that behind. But Sikorsky accepted me the third time and in. Sikorsky had finished up all this nonsense of extra rotors on the VS-300 and went back to the original configuration. A single main rotor, cyclically controlled, and an anti-torque tail rotor. The R4 had been almost ready to fly, had just been barely finished, and I jokingly say they must have sawed off the extra beams and so on for the extra rotors because they were anticipating doing something of that sort with the R4 all over again. Well, they did not. And it was very shortly after that I got there as the 13th engineer to work completely on the helicopters. And during my 32 years, the engineering department grew to something like 1,500 engineers. And it's been a very satisfying experience in this 32 years. We went through, as we got bigger and bigger helicopters, 3 different configuration of clutches, and there are a lot of detailed stories that I could tell you, but I will not bore you with that. My chief part of my time at Sikorsky was as chief development engineer on all of, mostly a mechanical type engineer, and the helicopter is very mechanical. So I had many times chance to improve helicopters to make them last longer and be better maintained, more maintainable and reliable, and it has been a very, very satisfactory experience for me. Thank you.
I think you can say that not only persistence pays off in developing a helicopter, but persistence pays off in getting a job in the helicopter industry, too. We have quite a contingent from Mil today. Marat Tashenko is going to introduce our distinguished guests, and then there'll be a video on the Mil developments.
Ladies and gentlemen, at first I want to say thank you to person who decide arrange this meeting. Second, I want to say thank you to headquarters of American Helicopter Society, which organized this meeting. And third, I want to say thank you, Professor Proti, who spent so effort and time for this meeting. Unfortunately, my English is not so good, and I ask help me professional translator Andrei.
I'm an engineer. I'm not a professional translator, but I hope my English will be more or less understandable.
В развитии любого вида техники сейчас главную роль играют коллективы, создающие эту технику.
Human factor is becoming more and more important in any brand of industry. Helicopter industry is included.
Однако главную роль играет руководитель.
However, the manager, the top person of a company is of major importance.
Поэтому сегодня, когда мы говорим об истории американского вертолетостроения, мы вспоминаем Сикорского, Песецкого, Камана, Раймонда Янга и других пионеров американского вертолетостроения.
Now, when we are speaking about the history of American helicopter industry, we remember such names as Sikorsky, Piasecki, Raymond Young, Kaman, and other pioneers of Sikorsky helicopter industry.
Именно поэтому мой коллега Сергей Михеев говорил о Николае Ильиче Камове.
Therefore, my colleague, Dr. Sergei Mikheyev, spoke about their founder, Dr. Kamov.
И мы начинаем свое выступление с добрых слов, посвященных Михаилу Леонидовичу Милю, организатору нашего конструкторского бюро.
And we are starting our presentation with the good works, good commemoration of our founder, Dr. Mill.
Именно его энергия, целеустремленность и преданность вертолетам позволила создать уникальный коллектив, который создал хорошо известные вертолеты марки Ми.
He was very devoted to this field of industry, and his energy enabled to create such a group of engineers, such a collective, which are now responsible for all the helicopters of Mill series.
Я рад представить почтенному собранию ближайших коллег доктора Миля и ветеранов конструкторского бюро.
I am glad to present to the respectable audience the closest friends and colleagues of Dr. Mill and veterans of Mill Company.
Здесь присутствует доктор Браверман, который является практически с самого начала существования фирмы 1948 года руководителем работ по аэродинамике.
And now in the audience we have Dr. Braverman, who works at Mill since 1948, and he is a leader in aerodynamics at Mill.
Я хочу представить Бориса Сиротинского, который работает на фирме с 1951 года и руководит отделом проектирования лопастей.
Mr. Boris Sirotinsky works at Mill since 1951, and he is responsible for Mill blade department.
Я хочу представить Евгения Яблонского, который работает на фирме Миля с 1953 года и сейчас руководит проектированием систем вооружения для вертолетов.
Mr. Eugene Yablonsky works at Mill since 1953, and now his responsibility is weapon system integration.
Я хочу представить вам уникального летчика, который сейчас, несмотря на то, что ему уже 87 лет, работает в конструкторском бюро Миля. Это Федор Прокопенко.
Let me introduce to you a unique test pilot of the helicopters, Mr. Fyodor Prokopenko. He is 87 now, but he is still working at Mill.
Прокопенко имеет уникальную биографию.
He has a unique background.
Он начал летать в 1935 году.
He started to fly in 1935.
Как пилот планера.
As a pilot of a glider.
Затем он был летчиком-истребителем.
Then he was a fighter pilot.
Он начал военные действия на третий день Второй мировой войны.
He was in the battle actions on the third day of the World War II.
Он участвовал в обороне Севастополя, а потом Сталинграда.
He took part in the defense operations near Sevastopol, that's a Russian city name, near Stalingrad, this name you know better, we believe.
Он сбил 16 вражеских самолетов.
He shot down 16 Nazi airplanes.
Он был в воздушном бою, его самолет был поврежден, и ему пришлось совершать вынужденную посадку на лес.
His airplane was damaged, and he had a forced landing on the woods.
После этого он вылечился и с некоторыми ограничениями продолжал летать.
After he had badly wounded, and after recovery he was still allowed to fly with some limitations.
В 50-м году он был назначен заместителем командира подразделения, в которое пришли первые серийные вертолеты Ми.
In 1950, he was a deputy of a group which received the first serial production helicopters of MIL. They were MIL-1s.
Он летал на самых разных вертолетах, и фирмы Миля, и фирмы Камова, до 1976 года.
He was flying different types of helicopters, both MIL and Kamov companies, till 1976.
И он закончил свой путь в должности командира армейской авиации.
And his last position was the commander of Army Aviation of Russia.
Of Soviet Union.
Of Soviet Union, sorry.
Мы подготовили некоторый исторический фильм.
We have prepared some historical movie,
который, может быть, не очень вписывается в линию сегодняшнего совещания, но я надеюсь, что совещание нас простит.
It may not fit absolutely to the kind of presentations which we have now today. It's less historical than the others, but we believe it will be of interest to the audience.
В заключение моего выступления я хочу передать профессору Проути, который здесь представляет руководство Американского вертолетного общества, несколько сувениров.
To conclude my presentation, I would like to present and to give to Professor Proti few souvenirs we brought with us.
Это портрет доктора Милля.
This is a photo picture of Dr. Mill.
This is for American Helicopter Society gift from Mill Design Bureau.
Спасибо.
Don't mention. Следующее – это модель вертолета Ми-26, который, я думаю, не нуждается в специальных комментариях. Модель специально сделана очень маленькой, чтобы подчеркнуть, что на самом деле вертолет самый большой в мире.
This is the model of Mi-26 helicopter. It is the model is intentionally small to underline that the helicopter is the biggest in the world, biggest production. It's really huge.
И это история нашего конструкторского.
And this is the book for the library, your library. That's the history of Mill Design Bureau.
Thank you very much for attention.
Ladies and gentlemen, we're happy to take you with us on a short helicopter video journey, a kind of whirlwind round-the-world trip in time and space. In some 15 minutes, we'll cover a distance of more than 15,000 kilometers, with short stops in 10 out of the 80 countries that are marked on the map with small circles. This is where helicopters of the popular Mi class work or used to work. We thought it natural to begin the journey precisely from Moscow, since the capital of Russia is the center of helicopter building in this country. In particular, this is the site of the world-famous Experimental Design Bureau of the Moscow helicopter plant named after Mill, the founder of this firm. Choppers designed by the Bureau have been named me in his honor, while the plant itself, thanks to journalists, has been dubbed Mill's firm. Moscow in the second half of the 60s. This is the famous designer Mikhail Mill. Documentary shows Mill with his colleagues and pupils. Engineer Marat Tishenko was young at that time. He will replace famous Mill as chief designer in 1969. Next to Mill is Mark Weinberg, who in March of 1992 is to become the third chief designer of that firm. Let's listen to what he has to say in 1993. What is our firm today? It turns out 95% of all the helicopters that are made in our country, they bear the Me trademark. It has built 25,000 helicopters, 15,000 of which are flying today. It accounts for at least 1/3 of the hard currency Russia receives from the export of its aircraft. The Moscow countryside in 1993, the most powerful gunship in the world, Me-28 is in the air. Until his latest appointment, Weinberg was the leader of that program. Both the amazing possibilities of the chopper, as well as the creative possibilities of its designers, are on display. The machine develops an overload of up to 3 Gs. The craft has been put into serial production. One more Me is up in the air. The new 4-seater Me-34. It too can develop an overload of 3 Gs. All possible and impossible figures of aerobatics are executed. The Me-34 is a helicopter for world champions, and at the same time, it's an economic flying jeep. Its hourly consumption of fuel is a mere 45 kilograms. The first serial samples have already come off the line. Its takeoff weight is approximately 1 ton. This is the lightest helicopter the Mill firm. And this is the Me-12, the heaviest and grandest of all helicopters ever built by anyone. Paris, 1969. The Me-12 at La Bourget. Its world records have yet to be eclipsed by anyone. Payload 40 tons, takeoff weight 105 tons, an altitude of 2,000 meters. Papua New Guinea at the beginning of the 1990s. Russian helicopter leasing operations are carried out on a broad scale. Among them is the Me-26, the biggest chopper ever to be used for commercial purposes. Its bay can accommodate up to 20 tons of cargo and transport it up to 600 kilometers, and a cargo of 15 tons for a distance of up to 800 kilometers. Sweden, 1993. The crew of another Me-26 faces the difficult job of building a 40-kilometer-long high-powered transmission line in 10 working days. 144 pylons as high as a 10 or 12-story building must be installed in ready-made nests about 1 meter in diameter. The diameter of the butt of the pylon is 800 millimeters. The clearance between the pylon and the edge of the nest, which must not be damaged, is minimal. But even that is not the main difficulty. The system of external suspension, together with a 32-meter-long pylon, forms the 2-stage pendulum of great length, up to 50 meters. And it's very heavy, up to 20 tons, which in itself required a solution of serious problems in the field of dynamics. However, this highly complicated task is solved and work continues successfully. The heavy helicopters Me-26 and Me-10K have been working in Sweden on construction and installation projects since 1990. In 1993, the Me-26 participated in the construction of the biggest bridge in Europe by placing structures weighing up to 22 tons each. Western Europe at the end of the 60s. The heavy helicopters Me-6 and Me-10K demonstrate their flying technical and commercial possibilities in the countries of that region. Excerpts from newsreels of that time. The Me-6 in the Austrian Alps. In Switzerland over Bern. In Norway. France from 1990 to 1992. Here, with the help of the Me-26 and the Me-17, a whole number of leasing operations were carried out in the transportation of mining equipment, road building equipment, bulldozers and such, as well as lifting out high-quality timber from the mountain. The Me-26 in the Pyrenees, and the Me-17 in the Alps. The French remembered most likely the group jump for parachutists in Vichy and Rion de Chateau near Paris during the annual international competition. Up to 135 sportsmen were in the air simultaneously aboard the Me-26. One might ask how this came about. After all, Russian helicopters have no Western certificates. By the way, neither do American or French helicopters have Russian certificates. Nevertheless, jet rangers worked about Moscow and gazelles over Russia along the route of the Paris-Moscow-Beijing autoroute. Life itself seems to suggest that national flying personnel depart from their old dogmas and make exclusions to the rules. A whole number of Western countries, Germany, Belgium, the Netherlands, Italy, Spain, Greece, and Cyprus, gave permission to carry out commercial operations employing Me helicopters, since in practice they won the international guarantee of reliability. Sakhalin in the 1970s, an island that is washed in the southwest sea of Japan. The Me-8 working on the construction of high-power transmission lines. It's noteworthy that Japan's Air Register was the first to issue a certificate to such a chopper purchased by a Japanese company meeting American standards. India from the 60s to the 90s. Military and civilian versions of Me's made up more than half the helicopter pool of that big country. It was only in 1993 when it first became necessary that India's Aviation Register issued a certificate for the passenger type Me-172, also on the basis of American standards. Afghanistan interfered from the 70s to the 80s. No doubt, military specialists are well aware of the Afghan effect from the extensive use of Me gunships, the limited contingent of troops, thanks to the use of helicopters, in spite of unending attacks by a greatly superior enemy, in the course of 8 years, controlled all the important centers, territories, and transportation arteries of that mountain country. Invaluable aid for United Nations troops being used in hotspots around the world. The Caucasus, now the territories of new states in the 80s. Here, complicated construction of high-power transmission lines in the mountains became possible only thanks to the use of the flying crane, the Me-10K. The Pamirs, the root of the world, now also the territories of new countries in the 70s and 80s. Me helicopters here became one of the main and sometimes only passenger delivery service. The Me-8 is the helicopter most often used here. Russia, the 70s and 80s, and the beginning of the 90s. The main forces of the Me helicopter fleet are, of course, in this country, but they are spread out all over the region. A substantial part of the craft are working in the most remote areas with severe northern climate, but unusually rich with oil, gold, diamonds, and other minerals. For instance, in Kamchatka, Siberia, and others. Besides the conventional, the state system of monitoring the technical state of helicopters in Russia includes the so-called author's inspection on the part of the designing firm, in the given case, the mill firm. Any easing of the author's inspection can lead to higher accident rates. Meanwhile, some 6,000 Me helicopters are now flying outside Russia. Mule specialists know nothing about the technical state of many of them. In the main, this concerns those machines that were bought on the black market at dumping prices. Observing all regulations, Me choppers are absolutely reliable even in conditions where Western analogs have not been designed for operating. However, this is not so easy to achieve, and it is not cheap. The Mule plants near Moscow, 1992, Dynamic Testing Laboratory. It was here that authoritative representatives from the United States Federation Aviation Agency carried out a painstaking study of the reliability of the Me-26, of which there are no analogs in the world, and noted that the dynamic tests of helicopter structures, as well as tests for repeated static gliding of the Me helicopters, are much more stringent than at American companies. Once again, in Moscow, in the 90s, the Me-10K and the Me-26 on a construction project right over the city. Is this not an indication of complete trust in its reliability on the part of the Air Register? In 1991, representatives of the U.S. Federal Aviation Agency and Russia's Air Register signed a protocol which, among other things, declares the Rotorcraft Directorate is now in a position to inform the FAA on the suitability of the new model Me-26T type design for external load operations. Ukraine, 1986. Me helicopters mopping up the consequences of the Chernobyl disaster. A few words about their strategic reliability. Several years after that event, a major physicist evaluating the Rowley plate said, "You want to build an atomic power station? Then tell me what kind of helicopters you have, and I'll tell you whether it's worth doing it." Our Me-26 helicopter over the waters of the North Sea belonging to the Netherlands. It was the first Western country that purchased the Me-8 and Me-10 back in 1965. Later they were resold to the Petroleum Helicopter Company of the United States. The helicopter hovers over one of the many overwhelming platforms here. Businessmen and journalists are on board. They're discussing a major project involving the use of giant helicopters. However, that's already another story, all the more so since it's shrouded in a veil of confidentiality. The expedition returns to the shore. And our journey is coming to an end. Our craft is coming down for a landing. We complete our round-the-world trip in Holland. We do hope that you found it interesting, and thanks for being with us.
Time for at least a couple in here. So, John Pisecki, are you ready? John is, of course, standing in for his father, Frank.
I don't know if this is maybe we were out to say a few words. Good afternoon, everybody. I'm John Pisecki, and I'm representing my dad, Frank, who sends his regards and apologizes for not being here. He had a stroke a few years ago, so traveling for him is difficult. But he's still coming to work almost every day, and he's still kicking my rear end from one side of the office to the other, so he's doing pretty well. My brother Fred and I are working with him on helicopter research. I've got a tape here today that got a tape here today that covers some of the history of his achievements. But before I play that tape, I did want to make some comments from my perspective as his son, and somebody who's witnessed a lot of people and efforts that he and his gang worked over the years, and I just wanted to relate some of my perspectives. First of all, the age of a lot of the people at this time doing helicopter development was incredibly young. My dad was 24 when he and his fellow students from the University of Pennsylvania achieved their first flight in the PV-2. And I think it's a real testimony to their accomplishments that they did it at such a young age. The other thing is that one of the points that he's made to me over the years, it's not one person who creates an invention. Every person builds on the knowledge and the failures of the people before him. I remember we were at some reception, and somebody came up to my dad and said, Frank Piasecki, nice to meet you. You're a real pioneer in the industry and what have you. And Dad said, thank you very much. And when he walked away, he leaned over to me and said, John, you know how you can tell who the pioneers are? They're the ones with the arrows in their ass. So he understood that the achievements that we all are admiring today are the products of lots of people's work. In particular, with respect to his activities, Elliot Daland was probably the most important influence in his technical career, and other people like Don Myers and Ken Meenan helped him design and then build these aircraft you'll see today. The other thing that I think is pretty interesting in seeing all the work that everybody is presenting today is the vision that was required by these people. With respect to the achievements of the Piasecki crew, the PV-2, which was the second successful helicopter in the United States, the technical achievement of dynamically balancing the rotor blades was probably the most important achievement there. And then the vision to be able to think big and think large about what helicopters could do, which led to the development of the tandem helicopter, which had a capability of about 3 times the helicopters at the time. Which really led to the practical application of helicopters with the Navy, which had that requirement for 1,800 pounds useful load before they would really consider these novel machines. The next element that I want to pay tribute to is the courage that these young developers had. I was talking to a gentleman by the name of George Brooks. I don't know if he's still here. Yeah, here he's right down there. And he was talking to me about doing a dynamic analysis on the H-25, the HUP. And we made the joke that in those days, you built the helicopters and then you analyzed them afterwards, as opposed to today when we analyze and then build. So in many cases, these people were flying machines that had no certainty of them being successful. So I think that took a lot of courage, and it's a real tribute to their success. And then the final, probably the most important element of all of the characteristics that I've noticed in all the presentations today is persistence. Especially when you're doing things that don't easily lend themselves to analysis or prediction, having the persistence to continue time and time again in the face of failure to go until you can achieve your objectives is an admirable attribute. Without further ado, then, I will let this video be played, and thank you all very much, and congratulations to all the many pioneers that are being paid tribute to here today.
Thank you, John. Says
the Boeing VTOL Chinook, the Western world's standard medium-lift helicopter for almost 30 years. Immediately recognizable with its 2 rotors, one in front and one at the rear. designed specifically for lift, was also a tandem rotor design. The forefather of the Chinook, the Piasecki HRP-1, was better known as the Flying Banana. The prototype first flew in 1947 in Philadelphia, the home of helicopter pioneer Frank Piasecki.
Philadelphia was sort of the center of rotary wing activity. And it was mainly because the Pitcairn family, Harold Pitcairn in particular, brought the Sierra patents from the British Sierra Company to the U.S. and set up a company in Willow Grove to manufacture autogyros.
For a young engineer, 1930s Philadelphia was an exciting town. Other rotorcraft manufacturers had followed Pitcairn's lead and set up factories there. Frank Piasecki took a ride in an autogyro and was hooked. He graduated in aeronautical engineering and went to work at the Platt-LePage Aircraft Corporation, manufacturers of the XR-1, America's first military helicopter. But Frank wasn't fulfilled by his job at Platt-LePage. With a group of young engineers, he built his own helicopter, the PB-2. By April 1943, the aircraft was ready to fly.
But there were very few experienced pilots. There were about 7 people, Lou Levitt being one amongst them. And he wasn't available. And so when we thought it over, including the prices, we decided it was me who was going to be the pilot.
As a pilot, Frank Piasecki only had 14 hours of fixed-wing flying time. He had to teach himself to fly the PB-2. Frank was the son of Polish immigrants. When the day of the first flight came, he used the only available open space, the local Polish picnic ground. In spite of some tricky moments, the first flights were encouraging enough to warrant the PB-2 being fitted with a complete skin. In its new streamlined form, it was rolled out for a continuing series of test flights. The PB-2, with its dynamically balanced rotor blades and full cyclic pitch control, was seen by Piasecki as a technology demonstrator. As the designer and the pilot, he was in a perfect position to get it right.
And it was a sweetheart. It could do anything. It was very controllable machine.
The PB-2 was only the second American helicopter to be demonstrated in public, but Frank Piasecki had another audience in mind. He showed the PB-2 to the Navy and tried to interest them in a large transport helicopter. He had some definite ideas about a new approach.
We said we would be absolutely honest to ourselves as to the estimates of weight, structural strength, and all of the things required, so that we wouldn't come out with an absolute answer, but we would come out with a relative answer to each of the designs. And the tandem, no matter how we did it, no matter who did it in this comparison and calculation, the tandem always came out better. And the reason for it became fairly obvious. One, all of your power is going into lift, because the rotor, the counteracting the torque, was automatic by the fact that the 2 rotors turn in opposite directions. So that was fundamental.
But the Navy wasn't interested, and Piasecki took the idea to the Coast Guard. On New Year's Day 1944, he signed a contract with the Coast Guard to build an experimental helicopter. The first Piasecki tandem helicopter had the designation XHRPX, but to the Piasecki Company, it was known as the Dog Ship. The rotors of the Dog Ship had a diameter of 41 feet, and the fuselage was 48 feet long. It was designed to cruise at almost 100 miles an hour, and to carry a load that was unheard of for helicopters.
So our effective useful load of 1,900 pounds in those days was roughly 3 times the size of anything that was flying at that time.
At the time, dog ship was the world's largest helicopter. It could carry 2 crew and 10 passengers. It was powered by one Continental R975 engine, developing 450 horsepower. That engine drove both sets of rotors. Weight was crucial, and when the dog ship finally got a skin, it was made from the lightest available material, balloon cloth. The dog ship was not a prototype. It was seen as a flying mock-up. This way it was possible to measure its flight and control characteristics, with a view to improving them when the prototype was built. The dog ship could also be used for demonstration to prospective buyers. The Navy was now convinced, and it ordered 2 prototypes, designated HRP-1, for further testing. They had Pratt & Whitney R1340 radial engines of 600 horsepower. Like the dog ship, the prototype HRP-1s flew without a skin, and their performance was impressive enough for the Navy to place an order in June 1946 for 10 production models. Later, they ordered another 10. When the HRP-1 went into service in June 1947, the bent fuselage shape immediately created interest. From then on, it was stuck with the name Flying Banana.
People didn't realize why that shape was, but it was because you had to have clearance in the middle of the fuselage for the rotor blade flapping. And of course, as you flew forward and you tilted the machine, the front part of the machine was level, and the rear part was up as a rear pylon.
The skeptics had said the tandem rotor design would never work, but it did. In 1945, the U.S. Navy issued requirements for a compact utility and rescue helicopter to operate at sea. This Piasecki design, the Huck-1, made its first flight in October 1948. It won the naval competition against a Sikorsky single rotor design and went into service in 1949. The overlapping rotors gave it an advantage in the cramped space of small aircraft carriers.
This made it possible for the design to be brought up into the carrier elevator, the rear rotor unlocked and phased properly so that its blades were in the proper corners and the front rotor in the proper corners, and then dropped immediately without any folding of the blades, which made a tremendous time advantage to the overlap tandem.
But the overlapping rotors produced more downwash than single rotor helicopters.
Because the downwash of one rotor added to the downwash of the other. So you had a bigger downwash in the center, but we had enough blade area and enough power, and we were so much more efficient than the single rotor that didn't really bother us.
339 Piasecki Hub helicopters were built, and they gave 20 years of service to military forces in the U.S., Canada, and France. The HRP-2 was an improved version of the original HRP-1 Flying Banana. The pilot now sat forward of the front rotor, and the helicopter was given a metal skin. Its successor, the H-21 Workhorse, was designed at the height of the Cold War as a high-altitude rescue helicopter, able to pick up returning bomber crews if they went down to the mountains of Alaska. It was a challenge to any new pilot.
We found that when the pilot made a hovering turn, he made it about himself. And he became the center of the turn, and the rest of the machine went all around him. You could, if you forced yourself as a pilot, rotate the machine exactly on its center of gravity. But that meant that you were flying sideways with the tip of the machine, with the end of the machine, and so you were going laterally and around in a circle yourself, which wasn't exactly what a pilot likes to do.
The workhorse was given a larger engine and rotor system to cope with the possibility of rescues at high altitude. Two massive drive shafts connected the 1,425 horsepower engine to the front and rear rotors. The rotor diameter was now 44 feet, and drive shaft maintenance was crucial to the safety of these large tandem helicopters. The H-21 lived up to its name. It was a real workhorse, able to operate in a variety of configurations and perform many different jobs. In 1955, the H-21 was adapted for testing in quite a new role.
And because of its size, weight, and capacity of about 13,000 pounds gross weight, it was used as the test bed to mount the machine guns down at Fort Rucker. And I was there when they were mounting a 50 caliber machine gun on the front landing gear because it was expeditious to do that.
This H-21 bristled with guns in almost every possible location. The workhorse became the first helicopter to go into service with 50 caliber machine guns when the French used them as gun platforms in Algeria. But its major war service took place in Vietnam in the early years of American non-combat support to the South Vietnamese Army from 1961 to 1963. When the Piasecki H-16 made its first flight on October 23, 1953, it was the largest helicopter in the world. Its rotor diameter was 82 feet, almost twice that of the H-21 workhorse. Powering this monster was a design challenge.
It was originally with two piston engines, one at each end of the aircraft, in their own engine rooms. It was quite interesting how everybody was enhanced by the fact that here was a helicopter that had an engine room.
The huge overlapping rotors were made of aluminum skin with a honeycomb composite filling. The H-16's fuselage had the capacity of a 4-engine airliner and could lift up to 14,000 pounds.
We later on in the second model went to turbines, and we had two turbines driving the machine. It was very successful and had 82-foot diameter rotors. But the RPM was so slow that any vibratory motion from the rotors, which were 3-bladed, would come in almost as a loping action. And you could actually almost see the rotor blades turning. You could actually watch the blade as it turned around.
The turbine engines chosen for the YH-16A were Allison T-38 turboshafts, each delivering 1,800 horsepower. The helicopter in this turbine-powered form first flew in 1955. In this form, the YH-16A was known as the Turbo Transporter. In 1955, Frank Piasecki left the company. It was renamed VTOL. Piasecki formed a new company, the Piasecki Aircraft Corporation. In early 1956, the YH-16A set an unofficial world speed record of 166 miles an hour. But shortly after, a test equipment failure caused it to crash, and hopes for a promising future were destroyed.
So we said, okay, let's not do anything with the tandem because that's been fairly well established, and so let's not fight against ourselves.
Having left the big tandem helicopter behind, Piasecki turned his attention to exploring designs for radical forms of rotorcraft. This is the prototype of the Flying Jeep Skycar, or Air Jeep. It was the winner of an Army competition for a vehicle that was invisible to radar because of its ability to follow the contours of the Earth and remain under the radar signal. It made its first flight in September 1958 with Frank Piasecki at the controls. Lift propulsion, and control all came from the ducted rotors. The pitch of each one could be changed independently, so the front or the rear could be lifted. A combination of cyclic pitch and vanes on the rotors gave directional control. The test program examined its potential as a stealthy weapons carrying system.
The Jeep was designed to fly under the trees, just feet off the ground, and under the foliage.
The next stage was a turbine-powered version, with the rotors mounted on an angle, but the project was shelved in the early 60s. By 1960, Piaseki's old company had been taken over by Boeing and became Boeing VTOL. It was heavily involved in the development of a new medium-lift tandem helicopter for the United States Army. That helicopter was designated CH-47, but it would become known worldwide as the Chinook. It couldn't have come at a better time. America was already involved in Vietnam, and the Piasecki H-21 stationed there were showing their age. When the Chinook arrived in Vietnam in 1965, it had a huge and immediate impact. Over 25 years later, new Chinooks are still being produced. 1962, at the Piasecki Aircraft Corporation, another of Frank Piaseki's innovative ideas was being tested. He'd been working on the design of a ducted fan, which could be fitted to the rear of a small single-rotor helicopter. The idea was to increase its speed in level flight. The testbed was the 16H-1 Pathfinder, Piaseki's first single main-rotor helicopter since the early PV-2. The fan system wasn't only used for forward speed. The helicopter's foot pedals operated vanes on the ringtail, as the fan was called, to counteract torque and give directional control. The next test bed was the 16H-1A Pathfinder II. Modifications had been sponsored by the Army and Navy, and its goal was speeds up to 230 miles an hour. It was a compound helicopter with a small wing to take the load off the rotor in forward flight. In tests, it showed off its extreme maneuverability. The Pathfinder II almost succeeded in reaching its speed target in level flight. It flew at 225 miles an hour. While the Pathfinder never went into production, the idea of the wood-tailed ducted fan system is still well and truly alive, and is currently being tested for use on a high-speed attack helicopter for the future. Frank Piasecki has been involved with helicopters for more than 50 years. His legacy of innovation has a continuing effect on the helicopter industry.
Thank you, John. We have a coffee break in 9 minutes. Which one of you guys has got a 9-minute presentation? Huh? You do? Tony? 5 minutes. Yes, just 5 minutes? All right. We'll let Jean Belay came all the way from France. I think maybe most of you know his test pilot experiences and his historical writing. Go ahead, John.
Thank you, Ray. The first post-war French helicopter was built in 1947. It was called the SE 3101, SE for Southeast Aeronautical Society. It was a small single engine equipped with a 100 horsepower engine. It had two tail rotors, like an inverted V at the end of transmissions going through the two stabilizers. The main rotor had been recovered from the side-by-side twin rotor Focke-Algelis helicopter. We took that turning in the same direction as compared with American helicopters, at the opposite direction as compared with American helicopters, a habit we have kept on French helicopters. Longitudinal control was achieved through the vertical component of the thrust of the tail rotors. By a differential piece variation, one could change the vertical component without changing the horizontal one. A rather unpleasant configuration because in case of tail rotor shaft failure, not only do you lose yaw control, which already makes the pilot task uneasy, but you also lose longitudinal control, which makes it hopeless. Furthermore, there was a waste of power since part of the power was used to create two vertical opposite components. Actually, it was marginal in power when the pilot in charge, Stackenberg, after months of tethered test, tried to take off. The three wheels remained stuck to the ground. I was the second pilot, young and thin. I tried and succeeded in hovering 1 foot off the ground. This was in June 1948. The picture was taken a few weeks after we improved the rotor blades. There was another drawback with this configuration, a sudden change in the vertical thrust of the tail rotor when going into forward speed because of the downflow of the main rotor interfering with the tail rotor blades. During my first forward flight, at an airspeed of about 20 knots, I experienced a sudden pitch up of the fuselage which pointed toward the sky, despite a full forward stick. All I could do was to maintain the heading while the helicopter was going down and backward. Fortunately, at the very last moment, the tail rotor going out of the main rotor flow recovered their thrust, which prevented the tail of the aircraft from hitting the ground. I landed with quite a good backward speed without damaging anything. Tu mets la deuxième photo. I avoided the crash that time, but there was another chance for the helicopter. In September 1948, I could make a public demonstration at Villacoublay, an airfield near Paris. Tu mets la troisième. A few months later, on the eve of the 1949 Paris Air Show, opening day, I had to perform an authorization landing to obtain the authorization to demonstrate the helicopter at the show. I had never done an authorization landing before. In those days, instructors were afraid of them and did not teach them. And flying the 3101 was somewhat tricky. There was no twist grip for controlling pitch and throttle, but two different handles. The clutch was not centrifugal but hydraulic, with a separate handle for clutching and clutching. It made three handles for one left hand. Furthermore, the pitch was not balanced. When I loosened the collective pitch handle in order to declutch and make the auto-rotation landing, the pitch increased by itself, causing a drop in RPM. I quickly pushed back the pitch handle, but decreasing the pitch led to a high rate of descent as I was on final approach. I could not avoid a hard landing. As there was no damper on the landing gear, one of the main wheels broke and the helicopter rolled over. But it was repaired within 10 days and I could demonstrate it on the very last day of the show in May 1949. Then I flew for another 2 flight hours, extended over several months, and the engine broke down. As there were no spare engine, the helicopter was sent to the Air Museum. Suivante. The following helicopter was the Alouette 1, tested in 1952-1953. Only 2 of them were built. We could not find a market for this helicopter. And at last, the Alouette 2, our first successful helicopter, flew in 1955. It was the start of our expansion. I thank you for your attention.
One thing that Jean did not tell you is that he set the altitude record for helicopters at 43,000 feet, as I remembered. It still stands. And he had a flame out, so he set another record for auto rotation from 43,000 feet. All right, the timing is very good. Let's take at least 20 minutes for a coffee break, and we'll come back, and we may be able to actually finish this by 5 o'clock.
I'll start out with a little background of how I got into the helicopter business. After a few years of working at the Martin Company and NACA, I wound up at the Air Corps at Wright Field, along with Hank Belkoff, who I'm sure you all know, and Lou Schuler, who was chief engineer at command. We were a bunch of buck privates who were given project engineering jobs at Wright Field because I guess they were short of people. And I started at the Prop Lab with Hank and then wound up in instrument flying training. So I was a project engineer in instrument flying training. And I learned that the Air Corps wanted a helicopter trainer, much like what the Coast Guard had at Floyd Bennett Field. So I sent a switch to the commander at Floyd Bennett Field, said a representative from Wright Field is going to visit your facility to look over your helicopter training. And I showed up in my corporal uniform and at Commander Erickson's office, and he looked me up and down. He said, "You're the representative from Wright Field?" I said, "Yes." He shoot me off to an enlisted person, and they showed me what they had. Years later at Sikorsky, I ran into Commander Erickson, and I tried to remind him of the incident, and he refused to remember. But that was my introduction to helicopters. Later on, I wound up at Sikorsky as assistant chief instructor at Sikorsky, and that was really an education. This is 1946, and Sikorsky really was a wonderful place to work. This article about the great point-to-point race that Igor Sikorsky started to show that cars leaving
the Sikorsky plant could get to Hartford, or not the car, but the helicopter could beat a car or train or any other means of transportation. I learned a lot from Igor. I hope that this doesn't cause any concern, but he was a great person to be around. And one of the things that he was always doing was working with Serge Bablov on building new parts of his house. But one of the things that I heard this morning that surprised me was the reference to the VS-300 Sesqui tandem rotor. And I had thought that when I was at Sikorsky that Igor would never build another tandem helicopter. But we built one for him based on an R4 fuselage. And this was a proposal that we gave to the Navy, hoping to interest them. But this was 85% thrust in the main rotor, 15% in the tail rotor, which had a slight tilt to counteract torque, plus a real tail rotor to provide maneuverability. Sikorsky was generous, and I was very active in the Helicopter Society, and they made a mistake of sending me to the 1955 Helicopter Society in Los Angeles, and while I was there, Ken Amer grabbed a hold of me and said, "Jack, how about coming out to see what we're doing?" And that was a mistake, because I wound up being in charge of helicopter development at Hughes for the next few years. And one of the first things we had to do was take Gitch Jovanovich's rotor head and rotor system and design it into the 269 helicopter. And I learned a lot on helicopter development from Miller Watts, working closely with him for many years. And I took the S58 tail rotor bearing to put it as the pitch change bearings in the Hughes 269, and it increased the life and made it much more serviceable. But one of the things that we were concerned about was ground resonance. You've heard the word, probably you've never seen it, but you're going to see it in a few minutes. You'll notice that the landing gear was just a spring landing gear, no oleos. And this is a fully articulated main rotor. So that my task was to prove that you could use this kind of landing gear. I'll skip to the answer later and then show you the videotape I have of the ground resonance test. Here I am as a fictitious captain in the air in the Army with Gail Moore as a pilot in the landing gear which we finally wound up using. But Gail was a pilot, and he was going to run this test on this rig, which was a hydraulically driven transmission, and this fuselage was free to move about. We had some tie downs as usual, and we'll look at the video. No, you don't. Gail Moore was supposed to be the pilot, and unfortunately, in the middle of the test, he got the mumps, and he had to stay away. And so I said, well, heck, I want to get the test over with, so I sat in for him. that I did because he was a good head taller than I, and I wore his helmet in here, and you'll see that when we got into resonance, the rotor blade just skinned the top of my helmet. If he'd have been in there, that would have been the end. We kept trying to develop ground resonance as we raised pitch and shook the stick. You'll see that somewhere along the, I think that's Ken Amer standing watching. Now don't take your eyes off it because it happens very fast. It happens when you're about 90% lift.
I don't think it's going to happen, Jack.
You know it does. This is a video that Ray... It happened. This is a video that Ray Prouty has made sure that all new employees that use have watched. You want to see it again?
When I show it, I've got it twice on my tape.
Oh,
Oh, hold it down.
that destruction took 1 2/3 seconds by counting frames.
All right, now I'll let it go again. Notice he changed jacket in between those two shots.
Different day. If there are any questions?
Now that most of you have come back at 2 administrative things. There's a list going around of attendance sheet. If you haven't signed it, see if you can find it in the back and someplace and sign it, and it's going to be typed up eventually. Another thing, you notice that we have a professional video maker over here who has been taking videos of everything except maybe the the videos which don't show up for you. This is eventually going to be edited, and it is going to be available to anybody for a slight charge, and that hasn't been decided yet. But if you would like to get your name on the shopping list here, leave a business card with my assistant over here, or just a slip of paper with your address and everything on it, and we'll get you on a list and tell you when this video is going to be available. The other thing, I have copies of many of the biographies of the people who were talking today. I had Rhett Flater asked me how many I wanted, and I said, well, I want at least enough to cover all of the pioneers, about 50, and he sort of blanched, but he did have 50 made. So I have passed these out to a number of you people who were on my engineering pioneer, my pioneer list, after the meeting, come up here and pick up your copy if you didn't get one. If there's any left over, then that's for you non-pioneers. But I want to make sure the pioneers get these first. The next presenter on the list is George Brooks, who I knew many years ago as
I bring you greetings from the Langley Research Center. It seems that everybody there is becoming mobile now, and now that we've lost our guest, our carpenter, the only mobile person around there, I guess, who worked back in those days seems to be me anymore. So I'm real happy to be here, you know, because Gustafson sent his best wishes to everybody, but unfortunately he didn't feel healthy enough to join you. After I joined the Navy the day after Pearl Harbor, and after 3 years in the North Atlantic and South Pacific, the Navy decided they'd send me back to school to see if they could make an officer and a gentleman out of me. They sent me to Hampton Sydney College, and when I got there, I met Bob Lynn, who was already a gentleman. And later on, we were transferred to Princeton, and Bob and I went through the system together. It was really a privilege to be there under the tutelage of Professor Nikolsky, really a fine gentleman. In 1949, I went to the Langley Research Center, and during that year, there were a couple of people from Hughes showed up. And I guess I had taken a course in helicopters and a course in vibrations at Princeton. And so I was chosen as the person to work with them. And what they were interested in was a dynamic model of the X-8-17 helicopter. Now, I don't know if you remember the X-8-17. Not very many of you saw it because it wasn't around very long. I'm pretty sure of that. But anyway, what the task was to build a model of that helicopter. Now, and when I'm talking about model, I'm talking about a complete aeroelastic dynamic simulation. Everything from the tires on up, where it was simulated. Because what they wanted to do was to use the results of these model tests to determine whether or not they could fly the helicopter. Well, somebody in Langley gave me $12,000 as a budget and said build a model. So that's the model. It's a result of $12,000. Now the people who helped, their time wasn't counted in there. If you look at this model, you'll see, for example, that this helicopter had some very unusual properties. First thing, I used compressed air because we had 4 jets at the tips of the blade out here, and there were burners on the X-8-17 helicopter, and the gas that was generated from the jets in the jet engines in the fuselage went up through the hub and out through the blades. Another very interesting feature of this helicopter was that it had straps here for the retention of the blades. These straps that went across and connected to the 2 sides. It had an unusual feature here. There was an inverted pendulum, which was spring-loaded so that if the hub moved relative to the fuselage, of course it was spring-restrained. Well, okay, let me show the next slide now. It had this will just give you a little better feel for the hub, and you can see the features that I was talking about. One thing that I could not do, of course, was to simulate the actual motions of the Schwartz plane. I had hydraulic pistons, but the lag and the lines were so high that the motion was faster than I could keep up with. So we used a new technique, the technique of tethering. Now, that wasn't tethering to keep from ground resonance.
The tethering, which you see here from these cables, were actually the cables that I used to control the helicopter. And I used them to bounce the helicopter around on the ground like you saw a while ago and everything else, trying to induce ground resonance if it existed. I never could get ground resonance on that helicopter model, so I think it was free. I think you could say that it was free of ground resonance. And the other problem we were concerned with was flutter. At that time, nobody had done any flutter analysis. I remember Langdon, was famous for his work in flutter. And one of the things I did one day when I got interested in this is go talk to some of the flutter people. And the answer they gave me was that if you stop the rotor, come back and talk to us. Well, I said, gee, if I stop the rotor, I don't have a helicopter anymore. But that was the status, I think, of helicopter flutter about 1950. This shows the design of the blades. And the most interesting thing, or the most difficult thing for making this model was to find tubes that would carry this compressed air out to the tip jet, which had no stiffness and no weight and carried 85 pounds of pressure. Well, I made some, and they're still working. They worked three years ago when we tested them. And what I did was to take a piece of plastic that you run electric wires through, put it on a piece of pipe. I put some holes in the pipe so that I could put the air pressure to get it back on. Put this plastic, I wrapped a piece of aircraft linen, cigarette fashion. That's what I called it in the report, if you ever read the report. And then I did a spiral wire in the two directions. So it essentially weighed very, very little, but it was very, very strong and lasted, for a lot of years. And that shows the interior design. Now this blade had two counterweights. One of them is, you can see out here the tip, and then there was another one which was inboard here. And that was primarily due to the fact that if you're worried about flutter, you need to have your center of gravity of your blade or wing or what have you forward of the quarter cord. You couldn't do that with this design, so the counterweights were out at the tip and the inboard or to settle that issue. Okay, so we went into flying, and what was surprising, what this shows is that these two marks here are one per rev. It showed that we have a very large bending stress, free per rev, and but very little torsional stress. And I remember them telling me, said, you've got something wrong there. That can't be true. You don't get free per rev vibrations out of a two-bladed rotor. Well, there's free per rev vibrations, and there was a two-bladed rotor. Well, anyway, so by the time these tests were completed, Hughes was ready to do their test on their full-scale vehicle. They did a short flight. They came down and looked at the oscillograph records that they had, and they found exactly the same thing that the model showed. Then they came back to us and they said, well, gee, what can we do to fix it? So we went back, took the blade, went back and did tests outside of a wind tunnel, and then the return pass for the full-scale tunnel, and the result came out exactly the same. And so far as I know, they told me that the helicopter had a fatigue life, estimated fatigue life for 5 minutes. Whether it ever flew again or not, I have no idea. I remember going out to Los Angeles a few times and seeing it sitting out on the edge. Why was this a problem? Here's the reason it was a problem. You see, we're operating out here. This is your normal road speed, and you can see you've almost got a resonant condition between the free per rev flying and the blade bending, first to after blade bending frequency. And that was due, of course, to the value of the Southwell coefficient, as you recall, which is the thing that determines the difference between the natural frequencies of the blades when they're rotating and when they're not rotating. And that Southwell coefficient was such on those blades with the counterweights that it caused basically a condition of resonance there. At least it was high enough so that it had very high bending stresses in it. Well, so much for that. Maybe somebody else knows what finally happened to it. Then I took the model and I used it for several years for all kinds of research. And I got plenty flutter, but, and you can see, for example, that if you look at the blade, various blade frequencies here, and you can see the buildup. Well, that was the incidence of flutter. And what I did to get the flutter, of course, was reduce the pitch stiffness. And of course, and when you have a system like that, the anisymmetric system is always more sensitive than the symmetric system because you know, the bending is helping each other in each direction that you go. And the flutter that we got was almost cyclic blade motion. This flutter had, there was a couple of very interesting things that happened. First thing was that I needed to measure the frequency of the flutter, and I wanted to get a picture of it. And so I went over to the instrument people and I said, I'd like to take some pictures of a helicopter blade roll fluttering. And so they said, well, it'll take about 3 months to develop the system, and it will cost something of the order of $3,000 for the instrumentation. So I went back and I got a piece of pipe and I drilled several holes in it, put micro switches in it, found the ball bearing, turned it loose at one end. As it went down the pipe, it set off the micro switches, fired the film as it went around, and I got the, I think it was probably the first major pictures of flutter that ever occurred. But it was a very interesting thing to do, and I enjoyed it. One of the last things I did before I went into space work was to, working on my doctoral dissertation, I had the feeling that this mechanical instability that you call ground resonance, if you had multiple degrees of freedom in your system, you'd have multiple degrees of instability. And that was what I set out to prove, and that's what I did prove with this model. And I did the calculations, the theory on it, and then I did the measurements, and correlated those, and that's exactly what happened. So when you see these tall things sitting on the end of a wing, you know, don't forget, they're very good candidates for mechanical instability, which we call ground resonance, except that it can occur in the air. And your fuselage is basically acting as your ground, and you got your flexibility in your wings, etc. So now that was published in my doctoral dissertation in 1962. I happen to have a couple of pictures here that I thought were kind of interesting. I'll just show you these. I saw these guys this morning all around these helicopters kind of close. And the one you had a while ago kind of tickled me too. This happened to be a pitch-carrying auto gyro. I'm glad I wasn't anywhere close to it, I can tell you that. That of course, is one of these cases of mechanical instability or ground resonance. Thank you, ladies and gentlemen.
Let me make a comment about the life of the A-17 blade. The man who would know the answer, unfortunately, Clay Boswell, died about a month ago.
Is that right? I didn't know. Well, I made a lot of other models that, you know, over the years. I guess I worked in helicopters for about 14 years, and it was a fun thing to do. After that, I retired as a direct constructor at Langley, but that wasn't any fun thing to do. I mean, pretty soon, when the research is gone, the fun is pretty much gone too, and that was what we really learned. Thank you.
I can't help but put a footnote on that. Those blades were originally designed to be bonded. This was 1947 or so, and they couldn't get the bonding technique right. So they decided they're going to rivet those blades. So they had 10,000 stress risers in there. And Clay Boswell would calculate how long that blade is going to last, and in briefings for the flight, the pilot, Gail Moore, would say, is it okay? And Boswell would say, oh yeah, it's good for 10 hours, though he may have calculated only 15 minutes. But the flights were very short. They just went down the runway one way, landed, and towed it back. So, but unfortunately, nothing is left of that particular helicopter. It was just scrapped. This morning you heard something about the Cheyenne when Don Segner was talking about it. Al Yakler and I and Norm Gornberg are Cheyenne pioneers, and now Al is going to talk about his experiences before Cheyenne. Al?
Thank you, Ray. Before I went to Lockheed working on the Cheyenne, and Ray told me I shouldn't talk about it today. However, I worked at Kellett Aircraft. And Kellett has an interesting background in the helicopter industry. I just thought I'd review that for you, where Kellett, in the autogyro business, was trying to convert from autogyros into that of the helicopter business. And I joined them in 1946, working on a helicopter. And then it turned out that the last presenter that you saw talked about the XR-17. That was a program that started at Kellett in 1946. And my first job at Kellett was working on that XR-17. Young kid out of school, really had some challenging problems with that bird. So what I'd like to do first of all, though, is go back for Kellett and show you one of the autogyros that Kellett built, and they actually had operational experience on it. So on the next slide, this is the autogyro in operational use. It operated from the post office roof in Philadelphia, delivering mail to the Camden airport. And they actually had a very successful operational experience. I have some numbers here. I'm going to just read them to you. I can't... They had scheduled operational trips, 3,050. This is all in 1 year time period. Canceled trips, 443, represented about 14.4% of that. The trips that therefore were operated were 2,607. Now all of that in a time period in 1939, they operated as an autogyro off the roof of the post office in Philadelphia, 30th Street Station. The failures for not being able to operate, most of it was because of weather. 286 cancellations were because of the weather. It amounted then to total trips that were canceled, that is, 443, 14.4%. The trips were delayed because mail was delayed. 393 of those trips were canceled because the mail didn't make it. So the aircraft actually performed very well as an operational vehicle in those days. I wasn't there at the time, but it's the history of Kellett Autogyro. So on the next one, as I mentioned, Kellett was coming away from the autogyro experience. And this is some background of other autogyros that were built in those days, showing what the future of the autogyros would be. On the next one was Kellett getting into the helicopter business. In 1943, they were awarded a contract with the XRE. This is a syncopter helicopter. It was an experimental vehicle just to explore what the advantages of it were, awarded to Kellett,
where Sikorsky had the single rotor with the tail rotor on it, and some people felt in those days that a syncropter would be more efficient. You don't have the tail rotor. This aircraft performed quite well. One of my first jobs at Kellett, when they were doing some experimental work referring to that of ground residence, they had a procedure there of fastening cables to the bottom of the aircraft. And the people then were assigned at the end of these cables, if they got into a ground residence situation, you could see by the way the aircraft would vibrate, we were supposed to pull on those cables. I didn't know what we were doing at that time, and when I saw Jack's picture there, I said, I'm glad I didn't know. So this was the experience that we had trying to come out of the autogyro business into the helicopter business. The next contract that Kellett had was an award of the XR-10 aircraft. Now, in those days, the Air Force was interested in trying to carry cargo. So here we had twin engines, one on each side, and the cargo bay area was left clear so that you could carry passengers. This aircraft, again, was a syncropter, just a next version from that of the XR-8, and Kellett had a competition. They actually won the contract and designed and built this aircraft where it was going to eventually, in the eyes of Kellett, wanted to have a commercial version made. And I know the first time I went into the Kellett facilities back there in '46, they had a beautiful version of a commercial version, 10-passenger of this aircraft. On the next one then, there's the XR-17 aircraft that Kellett started before it went to Hughes. About the same time period, Kellett went into financial difficulties, and they had to try to save their company, and this is where they sold the rights and the actual hardware that we built on the XR-17 to Howard Hughes. The total contract, some of the people went with it. They finished it out on the West Coast as an aircraft, and as Ray mentioned, after it was designed and built, there were some difficulties. I must admit, this was quite a challenge for a small company like Kellett to take it on. So you can see the size of it. It's not by the model here. This is the real aircraft. And it was large enough to carry, supposedly, like the old lumber trucks back in Philadelphia those days, to fly over an aircraft over the automobile and pick it up. Okay, and the next one then, Barney, is later on, Kellett wanted to get into an easier-to-fly aircraft, and they got an award of an experimental contract for stable Mabel. This was the term that was used for it, to experimentally evaluate handling qualities. We had a gyro on top of the aircraft, and this pilot then was to fly it, and he was able to fly it hands-off. It was a variable stability device where he could change the amount of stability into the rotor system for various phases. Back in those days, as someone mentioned earlier, we were told that in about 10 years from this time period, everybody was going to have a helicopter in your own backyard. Well, no way. So after this program here, it was not an engine on it, but we had rocket engines, little rockets on the tips of the blades, where we actually had an aircraft that was flying with hydrogen peroxide. Strictly an experimental aircraft and didn't go anyplace except give us some knowledge on stability and control. This was the beginning of some thoughts for a compound autogyro. We added a wing and 2 engines on it. But this was the thinking that they had in those days for how to make a compound configuration operate. On the next one then, As I mentioned earlier, I went to work for Lockheed and got involved into the rigid rotor development at Lockheed. And when I joined Lockheed, they had already started to, by decree, I'll say it that way, where the management of Lockheed gave the challenging job to Irv Culver to come up with a easy-to-fly vehicle where they thought at one time it was going to flood the market with low-cost, easy-to-fly vehicles for everybody's use. Well, we did, and the Model 286 was one of the first helicopters that we built, and it was easy to fly. We got it certified, and it was the first runner to that of an aircraft that went into a compound configuration and eventually into the Cheyenne that you heard Don Segner talk about today. At the same time, we were doing some experimental work on a stopped rotor configuration using the rigid rotor concept. In other words, the rigid rotor gave us a chance of looking not only at a helicopter with its good flying qualities, but also into a compound where you actually unloaded the rotor in forward flight and used the rotor then as an autogyro type rotor as a compound. And then also eventually a configuration could be done with a stopped rotor. On the next one then, the stopped rotor, the concept for the stopped rotor was to be able to fly it as a vehicle in a helicopter mode, go forward until 140 knots or thereabouts, where you could unload the rotor, stop the rotor, and then fly on the wing as an airplane, and you stow the rotor. In the next one, you'll show how this is the basic concept for it. The horsepower required on the first chart shows a typical helicopter horsepower required, and then you stop the rotor, as I mentioned, about 140 knots, and go down to a clean airplane configuration, and then go into an airplane mode, where in this case we could go out to a speed of 350, 370 knots as a typical airplane. And we went through some design studies of this, actually building a rotor, putting it into the wind tunnel. The next one will show some of the test results of this rotor. We stopped and started the rotor in the Ames wind tunnel at 140 knots. I can't see the numbers from here, but it shows that at 140 knots, angles up to 12 degrees, and and it actually matched up with the predictions over here, where we are able to calculate what its performance would have been. We had successful starts and stops on this for 55 times in the wind tunnel. Successful starts and stops in folding the blades. Okay. This is what an operational configuration by an artist concept would look like, where initially we had it as a compound with propellers on it. Eventually you could do it with a turbine engine and go faster. The concept lets itself unlimited in forward speed. It's a concept that we think would have an excellent potential even today yet. So in summary then, the lessons learned. We did in fact make an aircraft that was easy to fly. Some of the comments that we had from people that pilots that have flown it is that this is military pilots. They said, well, if it's this easy to fly, the generals won't need pilots anymore. They'll go out and fly it themselves. And it was, in fact, I don't know whether you gathered from Don Segner's comments this morning, an aircraft that was truly easy to fly. It was very stable. It had a control power on the rotor system because it was a rigid rotor concept. and highly damped. It had a high control power. I used to explain it that if you disturb that rotor, if you were hovering, disturb the rotor, it would go up and damp out very quickly, which made it the key to that of making a helicopter easy to fly. Even though in the early days we were told that everybody was going to have a helicopter in their backyard in about 10 years or so, don't believe it. It's not necessarily because of the helicopter, but I think because of the operational use. I can't imagine seeing 1,000 helicopters flying over Montreal. The rigid rotor concept isn't new. Actually, the Autogyro started earlier with it and still used the term. When Kellett was working on the XR8 and the XR10, they had some difficulties with the blades. Actually, we used to call it inter-smashing. They would actually contact themselves, and it wasn't a happy situation for it. But at that time, we were going to convert back to the rigid rotor and get rid of the flapping hinges, and that was at Kellett before Lockheed got involved. The rigid rotor, I think, has an excellent potential for a stop rotor configuration, and the stop rotor embodies some very inherent features to it, wherein it could operate as a compound helicopter or as an airplane or as the helicopter. It therefore means that it can be a vehicle that truly embodies the handling qualities of the helicopter as well as the speed and range and efficiency of a fixed-wing airplane. The forward speed is not limited as we have in as they have in the tilt rotor concepts today. And we have an ability to fly in two distinct modes, which means that if you ran into any difficulties, you can land it as an airplane or land it as a helicopter. And it embodies inherent features for stealth configuration, especially when it's in the airplane mode and you're folding the rotor. It can be made into a stealthy configuration. So just thought you'd like to know we did learn some lessons and applied them later on. Thank you.
As you know, we arranged the order of these presentations this morning by picking numbers out of a paper sack, and it turns out the next three presentations are all Sikorsky people. So Ed Katzenberger.
Ray?
Yeah.
5 seconds.
All right.
I've got a photo here of Sikorsky single blader.
Oh, I've heard about that.
Flight. I don't have a slide, but people might be interested in looking at it. This was Sikorsky approach to his folding motor, of course.
Strong, right?
Yeah, okay.
Okay. Little difficulty, but not much. John, my son, is going to turn the view graphs. I'm really very happy to be here and all, and see so many old friends and friendly old competitors. I don't know whether they feel that way still, but I do. Maybe I'm optimistic, I don't know. What I'm going to do is tell you first what I was asked to do. That is, what was I up to 50 years ago? Not everything, just helicopters. And then I will go into something that what I think is much more
interesting and significant. And that is what happened at the very beginning, between the very beginning and 50 years ago. I will not go into the present and tell you what glorious things Sikorsky helicopters can do now. John? I had these view graphs prepared because I thought there might be quite a number of you who do not recall what these helicopters looked like. They're so old now. This is the R5, the first one I worked on, which was, as you recall from this morning, was prepared as a design to be an aircraft to be placed on convoys during the war. You sat out in front there with nothing in front of you except some plexiglass. The footrests there could be converted into rudder pedals, and there was the collective to one side, and you could insert the stick. So if you wanted to, you could fly the aircraft. And that's what I did for a while back in 1944, showing that I had some feel for how this damn thing worked. As a matter of fact, the control forces were extremely high, about 20 pounds. We did not have servos at that time. And the other problem was, with the first models, we did not have an offset flapping hinge. And therefore, the control response, aside from the control being very difficult to use, our control response was somewhat over-delayed, you might say. You'd push the stick forward, and nothing happened for a while. And then you would decide to push it a little bit further, and then the whole thing came up like this. And that sort of thing. It was rather difficult, and I really was amazed at our chief test pilot at the time, Dmitri Wiener, who could fly this thing aerobatically the way it was at first. And there it is. I contributed to the design, but the big load on the design of this was carried by one of the real pioneers, a fellow named Bill Hunt. I've been in contact with Bill. I had been in contact with Bill over the years. I retired 26 years ago after 34 years at Sikorsky. I didn't know too much about what his career was, but I kept in touch with him until he died 2 years ago at the age of 91. No, about a year ago, last March, sorry. That's one of the early aircraft. John? Now, the first outgrowth of this, and what I'm going to describe really is the development of a species. One aircraft growing out of the experience of a prior aircraft. This is a direct result of the S-50, of the R5, the S-55. Now, of course, we realized that we could no longer put the engine directly under the rotor and have a very simple transmission system if we wanted to carry a variable payload instead of an observer, somebody looking for submarines. So this is what we did. Put the engine up forward, and the rest followed very nicely. We could put the variable load in the high real estate region right under the rotor, and it worked out to be quite a good start, but not exactly what we wanted. So when we came to the Navy request for an ASW aircraft, we took this design and enlarged it. Of course, we increased the power, and we came up with the S-58. Now, the S-58, I think, is much more familiar to most of you. It was a fantastically popular program, sold in the thousands, It was a fantastically easy development. We had no significant problems at all. It was quite unusual. It went like nothing. And the reason for that is that we had applied, we did not stretch our knowledge very far to go from our experience with the H5, with the H5 and S55 to derive this design, another evolution of the species. John? Now this was a horse of another color. Came out at about the same time, around 1952. We were committed to the S-58. We had high confidence about the S-58 because we knew practically everything we had to know to pull it off. This one was entirely different, presented serious problems. We really had to stretch whatever we knew. And it was from this design that I reminded our management that we had scraped the bottom of the barrel of our information, our knowledge, our techniques, our ingenuity in order to pull this one off. Had two reciprocating engines and bubbles out the side. That's what they look like. It was it had what we used to say, it had a built-in headwind. But anyway, somehow or other, after some serious problems, we did manage to pull off a very practical, reliable helicopter, not so much for the Marines, who were primarily interested in it, in developing their idea of vertical envelopment, but for the Army, as the H-37. This was not as successful as the 58 from the standpoint of the number that was made and the profit that was made from it, but we learned a tremendous lot. One of the things we learned was that we were very naive at the beginning. We had to hover at 6,000 feet, 95-degree atmosphere at normal gross weight. At the same time, we had to have a Vmax of 140 knots. That was a very difficult combination to pull out of the hat for a one rotor system. We had thought that all we had to do was increase the twist from 6 degrees to 12 degrees, take care of the hover efficiency, but that was not the case because we stubbed our toe very seriously from the standpoint of structures, vibratory loads and stresses on the rotor for the aluminum rotor was prohibitive. We could not continue with it. So we ended up actually not meeting that requirement, but we met the 140 knots because we had plenty of power. Now, I must also tell you that we had a machine that weighed over 30,000 pounds at that time. It was equivalent to the H-16, but instead of having two 82-foot rotors, it had one 72-foot rotor. The reason for its size, physical size, was that it had to fit initially on one of the small helicopter carriers that were used by the Marines at that time. Now, the lesson we learned, and which hurt us for a while, we learned it the hard way, became later the lesson that the military learned by requiring a risk reduction program as part of a proposal. I went to management and said, in effect, what turned out to be a risk reduction program, I said, we have to do some research. We did not have a research program at that time. And so I was able to start with a budget of 4 engineers. When I ended up at Sikorsky, back in 1976, our engineering budget was over $20 million a year. And it was a little bit bigger than 4 engineers. And I understand now it's probably in excess of $150 million, something of that sort. Some of the later members of Sikorsky probably given a much more accurate estimate. That was the lesson. That was a very important lesson. Since that, the S-56, we had a continuous build-up and an ongoing research program in anticipation of the almost inevitable increases in requirements to be specified by the services and by the commercial people. Now, I turn to the earlier developments right at the beginning. I will go on with this. This shows another further development of the species in the S-61. Again, building directly on the S-58 and the S-56. This ended up with the Black Hawk and a few other things like the S-64, the crane helicopter, and so on. But that is not really pertinent to this gathering. John, I think that would be the end of the biographs. At the very beginning, we had a small group, as Milliwaks explained, of about 15 people. And I was very lucky when I joined Sikorsky. I had been with Brewster for several years, Brewster Aeronautical, which had they had the honor of making probably the most inept fighter aircraft for World War II. And I worked on that, and I also worked on their dive bomber, and I eventually drifted over into armaments and got a couple of patents on that, and as to how you very quickly change an aircraft engine, a machine gun barrel after a sortie. The Navy insisted I take a couple of patents on that. Brewster wasn't interested for some reason. Anyway, so I joined Sikorsky early in 42. Luckily, before they froze you in your job. And that was a couple of months later. I joined in January. I worked for Bill Hunt, my mentor, my instructor, a very good British fellow, a very fine engineer whom I revere to this day, unfortunate in his career development to some degree. He had difficulties with our engineering manager at the time, and he had to leave. And I will tell you a rather unique story. I shouldn't say rather, unique after all is unique. And that is this, that there was the man appointed to be project engineer to replace Bill on the R5 happened to be very much disliked by the engineers who were going to have to work for him. I have no idea why they disliked him, but they came marching into the engineering manager, assistant manager's office and said, "We will not work for that man." So, big blow up. Igor went to the front office of the Vought Sikorsky group, and they said, "Sorry, Igor, you have to solve that problem yourself." Now, Igor, I must say, was a very, very brilliant designer. But that's what he really wanted to do. He wasn't really the kind of person to handle personnel problems. So what was suggested, I forgot who suggested it now, was that we mentioned, our management should appoint or nominate 4 candidates for the job. And that is how it came about that I was elected to be the project engineer by the engineering department. I was only 2 years up to that point, 2.5 years in the aircraft business. I won't mention what I did before. I was working for a laboratory, and I was thinking of becoming a physicist, which I was directed away from by my thermodynamics professor, whom I also revered, a real grand old man of thermodynamics, and said, "People don't know today what a physicist is." And I was a very poor boy, and he said, "I know you have to make money, so be an engineer." And of course, I had always been interested in aircraft anyway, absolutely fascinated by them. And of course, when I was 11 years old, you know, symbols have a great meaning for children. And Lindbergh flew the Atlantic on my birthday. And of course that, I was already fascinated by airplanes. So that's some personal ideas. Anyway, so we got started after the flying boat was finally canceled. And the fellow who was rejected, of course, naturally said, well, Katzenberger won't do it, he's a kid, and he's going to go flat on his face. Well, I was competing at that time with Ralph Alex. He was project engineer on the R6. The R6 was a development from the R4, a very much smaller helicopter. And we competed as to who's going to make the first flight, the R6 or the R5. Well, I won that competition. And this gave me a little more confidence than I had at the beginning. And as you all know, the R5 became the S-55. Now, I'll mention just one other thing to give you some of the, you might say, the local color of the business. Well, we had a problem with one of our guest pilots flying the R4 who failed to push the stick to collective down when his engine failed. Fortunately, he was close enough to the ground, and it was just the right height to be not quite in danger, but it was a terrible shake-up, and the airplane had a few minor things that came of that. So we were wondering now, what can we do to make the stick be pushed down when the engine fails? Obviously, we had to devise something that was sensitive to the engine. The engine goes out, automatically the pitch goes down, whether the pilot is daydreaming or not. So Jimmy Wiener, our chief test pilot, and we took the two doors off the side of the R5, put on seat-type parachutes, went over the Fairfield Marsh at 4,000 feet, hovered, and Jimmy pushed the stick and pushed the throttle forward, and the engine, not enough to put it out, but to put the RPM way down. And we had a Grumman flap actuator actually doing the job. Well, we fell 600 feet before you could blink your eyes, but the engine came back. I mean, the pitch went down, and we went into on a rotation. So, of course, Jimmy gladly pulled the throttle back, and we went home. So that showed that system could work, at least if we had enough distance between ourselves and the ground. We never went any further than that because it was never used, it was never considered really necessary, and we never did have another incident of a pilot daydreaming and not pushing the stick down. So that's how we left it. That's just one of the things we did. We did a number of other things that are not quite as dangerous, but were rather interesting. Like the pitch throttle synchronizing linkage, for example, a little twitch in our little device in our control system, which gave us a better synchronization between the pitch of the rotor and the throttle setting on the engine. That worked very nicely, first time out, and so it was used on all of our reciprocating models after that. I guess I've run out of my 10 minutes. So thank you for being attentive. Now going down is more difficult.
A real pioneer. Ted Carter, you're next on our list. The timing is good. We're going to run probably a little beyond 5. I do have a couple videos, one on development of the Bell helicopter and one on development of the Sikorsky helicopter, and I'm willing to stay and show those, but you people are no obligation to wait around. Ted.
Well, I think it was very fortuitous that I'm following up Ed, because I want to add to what he had to say that I don't think he anywhere near gave himself credit for his contribution not only to Sikorsky but to the AHS. Number one, in 1950 about, when Sikorsky a year or two before had lost the competition, we built the S-53 and it was beat out by the tandem Piasecki. HRP1 was it? I've forgotten the numbers. And then Bell suddenly jumped on the tandem bandwagon and beat us out for the ASW competition with the Navy. Things looked very, very bleak for the single rotor helicopter. And Ed was the one who came up with the concept. The problem was basically that we couldn't compete CG travel-wise. We couldn't get our payloads from no payload to full payload and keep the CG where the rotor could manage it. And Ed came up with the concept of pushing that engine forward, as you saw on the S-55, and combined it with the offset flapping hinge. And the S-55, I'm sure you all realize, is what put the single rotor helicopter back in the game. On top of that, Ed didn't mention that he, in fact, was the guy who really started the AHS. He and a couple of other guys sitting around over dinner one day came up with the idea. I know there a lot of people joined him very shortly thereafter, but I think he was, Ed, weren't you the first interim president? Is he still here? That's right. So we owe him a debt, both from Sikorsky's point of view and from the point of view of the AHS. Now, I'm a little embarrassed to be up here. I think that I ought to entitle this probably Second Generation Pioneer, or perhaps he also serves who fills in the gaps. I joined Sikorsky in 1946. I'd taken aeronautical engineering with Nick Nikolsky at Princeton, but then the Navy sidetracked me into amphibs, and I'd been bitten by the helicopter bug, and so I grabbed a job at Sikorsky right after the war, worked for Jack Chern for a couple of 3 or 4 months, and then was recruited by another guy who has never had the credit that he really deserves, and that's a fellow named Walt Gerstenberger. And really, he should be giving this talk, because what I'm going to talk about are how I was able to implement the ideas that he came up with, and got a great deal of satisfaction out of my early career because of it. Walt was basically a one-man chief of dynamics, and I became his sidekick, initially a gopher, and later the guy to develop the technology base to do what he wanted to do, and eventually essentially the project engineer on the HSS-1N that you saw in Don Sagner's talk. The 3 problems that Walt had me focus on were, number 1, vibration. Clearly, vibration was an insidious problem with every machine we were building and everybody else was building. And trying to develop some handle on where it was coming from, how you could mitigate it, was a high priority. I started on that about 1947, and I can remember sitting there with a mechanical calculator that you had to crank, and it did 1 digit at a time, and you could spend a week doing a single case of an iterative analysis to try to understand the mechanics of how the blade was interacting with the airframe to amplify the vibrations. We pretty quickly moved to a pragmatic approach of shake tests and the use of vibration absorbers. Initially, the thing that kind of bailed us out were cockpit absorbers. Later on, and by that time I'd handed this off to Ken Mard because Walt wanted me on something else, but things like the bifilar absorbers on the rotor heads that stayed tuned to the RPM of the rotor. But that was a real challenge, and it remained a challenge, I guess, for my whole career. However, the next job we had to face was a question of the control forces. You've heard a mention of that. Obviously, the S-51 was pushing the limit of size that could cope with the control forces that came out of that rotor. A lot of people were working on ingenious solutions to try to work with the inherent mechanics of the rotor to reduce them. Walt was a brute force guy. He said, they may work them out or they may not, but in the meantime, let's just fix the problem. And he sent me over to Chance Vought to learn what they knew about hydraulic servos. And as a result of that, we got into hydraulics in a very big way, very, very fast. And I think pretty quickly we had scooped the fixed wing industry. By the S-55, the S-55, we had a 4 degree of freedom, all hydraulic, irreversible powered control. The fixed wing people were still working with boosts and limiting their dependence upon it. Of course, the key to it was it had to be reliable. One nice thing about my job was it gave me a little time in the cockpit from time to time, and I'll never forget the first time we took off with the hydraulic servos installed, and Jim Chuders, the pilot, didn't want to turn them on until he got in the air, and so he took off, and in a hover, I pulled the handle that threw on the hydraulics, and Jim thought the stick had broken off in his hand. He couldn't believe what he was dealing with. He got us back down on the ground and took a long breath and then went on to fly it very comfortably. But hydraulic servos were really what it took to crack that size barrier. And then the next issue was IFR. The fact remained that if we were going to really contend for military missions, we clearly had to have an IFR capability. And that all got back to the fact that the helicopter really was a challenge to fly. And we suddenly realized that we really had a unique beast in our hands. A lot of people were working with the inherent stability and devices to try to mitigate the tendencies to instability in the helicopter. But it suddenly dawned on us the real problem was simply that we had 4 independent degrees of freedom in a hover, and each one of them the pilot had to try to manage independently. It was like trying to pat your head and scratch your stomach and slap your heel and rub your knee all at the same time. And so even if we could improve the stability of each degree of freedom, the demands on the operator were going to exceed what you would expect him to do in something like a night ASW mission. As a matter of fact, it suddenly occurred to us that for the first time we were trying to build a machine that didn't necessarily go the direction it was pointed. If you think about it, most man-operated machines have that virtue. They're a point-and-shoot device. The helicopter is anything but a point-and-shoot device, at least in a hover. And so again, Walt pointed us to the brute force approach. He packed me off to go up to MIT and work with Rene Miller and kind of match what Rene could tell us about the equations of motion of a helicopter, the stability characteristics, with the feedback control techniques that the Draper Lab was developing. And I came at just the right moment because the Draper Lab had just rediscovered the root locus approach to analyzing control systems. And in fact, the reason I joined the AHS in 1952 and qualified for this session was because I gave a paper on the root locus of the helicopter. But we came back to Sikorsky, put together the first automatic stabilization system, and again it was a question of drawing on what fixed wing knew, but then running circles beyond where they were. We realized that the autopilot approach that the fixed wing people did, that removed the pilot from direct control of the vehicle and put him on some kind of a joystick that then talked to the electronics that then worked the airplane, was not going to satisfy the pilot who was hovering at night at 30 feet over the water. And so Walt was the one who came up with the idea of the limited authority differential addition to the control by which the pilot was still on the stick and in command of the situation, and he was getting the assistance with about 25% of the authority of the full stick to keep him doing what it was that he thought he wanted to do. That had its opportunities to get into the cockpit too, and that was fun. And those sometimes were scary and sometimes they were comical. I can remember the first time we took Michael Glorov, Igor Sikorsky's #1 sidekick, up for a demonstration of the electronic stability system, and he put his hand on the stick and jerked it off and said he got a shock from the electronics, and he never did fly a stabilized helicopter. Well, I know our time is running out, but the ultimate answer, of course, to that was that we did get the IFR mission on instruments, and of course that had a lot of derivative benefits for other missions. But it was a great time to be filling in behind you true pioneers who laid out the basics for us and gave us something to work with.
Ted called me up a few days ago and said, I'm going to bring another pioneer. Will you introduce your other pioneer?
Well, I had the unusual situation of being married to a gal who flew a helicopter long before I got into the cockpit. My wife, Ann, was the first gal in this country to get a helicopter license, so I told Ray I thought he ought to let her into the meeting, and he agreed.
Tony Paradiso, you're on.
Well, I anticipated this was going to be a session in which everything is getting cramped. So what I've done is I've planned my presentation just like designing a woman's dress. It'll be long enough to cover the subject, but short enough to be interesting. I will talk about the forum. Mainly, it's a celebration of a birthday. Then I will have a video, excuse me, Jack, which will show the evolution of the VS-300. In 1940, at the beginning of my career, I became a member of the Society of Automotive Engineers and the Institute of Aeronautics at the recommendation of my mentor. He was very active in the professional societies. The advantage of the societies was evident when I was having lunch with brown bag lunch with a group of the engineers at Sikorsky Aircraft. This was in the late 1942. I had mentioned that the societies have the advantage of giving the engineers and other professionals in the group the benefit of listening to speakers who are leaders in their field, who are sharing their knowledge and experience on current production programs, and also learning about the plans for future programs. It was in late 1942 that I was having a brown bag lunch with a group of engineers at Sikorsky Aircraft that we initiated the idea of creating the American Helicopter Society. The meetings and the society began in 1943. In 1984, I had given the society my draft copy of the Constitution of the American Helicopter Society. This was at the 40th Annual Forum. And in 1950, at the 50th Annual Forum, I presented the American Helicopter Society with a 1/20th scale, museum quality model of the VS-300, which was the first practical helicopter in the United States. The model was not built from a kit. It was built from scratch by 3 model makers who were craftsmen, and they had spent about 600 hours putting it together. Sikorsky Aircraft provided me with drawings, photos, and videos so that the accuracy of the model would be assured. I have a video which I'd like to show now, showing the development of the VS-300. Among other things, you'll notice in one of the early drawings, there's a single rotor design. It's that single-bladed rotor. Get sound on. Oh.
Just a slight technical problem here.
I hope what hasn't happened was I didn't remove this video when I checked my baggage.
You want to start it over again?
Yeah, start it over.
All right, we're going to stop and leave one on. All right, now we'll start it again.
As I start to say, I didn't remove this video when I checked my baggage in at security at the airport, so I hope it didn't take out any of the contents.
Oh, I was pushing it.
Okay.
All right, here we go. Thank you.
Sikorsky had not only invented a working helicopter, he had created an industry. Today, Sikorsky is the largest designer and builder of medium and heavy lift helicopters in the world.
trace the evolutionary development of the VS-300A. The film clips are from Sikorsky Aircraft Film Library. This Sikorsky engineering drawing shows a single main rotor and a tail rotor, based on a single rotor design which Igor Sikorsky conceived in 1930. First flight took place on September 14, 1939. The helicopter was tethered so that it rose only a few feet and remained airborne for only a couple of minutes for each flight. Each flight fulfilled two needs: test the helicopter and help train the pilot. As shown by the video clip, controls remained a critical problem.
But by late 1939, Igor Sikorsky had built and was attempting to fly the first crude form of his VS-300 helicopter. The VS-300 had a cyclic pitch main rotor and a vertical tail rotor to control direction. But learning to fly it wasn't easy.
You have to lift the aircraft off the ground, teach yourself to hold it off the ground, say a foot or 2 or 3 feet off the ground, and then teach yourself how to be able to control the machine so that it stays within more or less 1 or 2 feet. That was the secret.
Part of this delay was caused by an incident on December 9, 1939. Serge Glurev was the pilot. Stability and control were still very limited. A simple, unexpected gust of wind was too much to deal with. Serge Glurev was not injured, but the VS-300 was.
There were major design changes made through the winter of 1939 through the spring of 1940. Flight testing resumed by May 1940. Now, note the extensive modifications made to the rotor system in the aft end of the helicopter. The single rotor was replaced with 2 horizontal rotors and 1 vertical rotor.
They decided to try this arrangement first with the machine mounted on a swiveling stand on the ground without having the main rotor installed at all. Here you see Mr. Sikorsky testing it out. And it seemed to work fairly well. This type of control was put into operation in March of 1940.
I stated earlier, I joined Sikorsky Aircraft in April 1941. On May 15, 1941, I saw a historical event. Igor Sikorsky piloted the VS-300 to a world record flight of 1 hour, 32 minutes, and 26 seconds.
In April 1941, Igor tackled the world helicopter endurance record with the VS-300 in this configuration. Sikorsky's new world record was 1 hour, 32 minutes, and 26 seconds.
In August 1941, the tail rotor system was modified again. The 2 horizontal tail rotors were replaced by a single rotor mounted on a tower. This design change restored partial cyclic control in the main rotor.
Les Morris's first flight with the new control layout was a revelation. He was able to do forward runs of 70 miles an hour, quick stops, backup, and do things they'd only dreamed of with the old system, and no problems developed. Even so, Igor Sikorsky decided that this was not the right control system for the new Army helicopter, the Sikorsky XR-4. And since the VS-300 was the test vehicle, it would be modified to test the next stage of control development.
The horizontal tail rotor was discarded to return full cyclic pitch control to the main rotor. Full cyclic and collective control in the main rotor was achieved on October 1941.
The final configuration of the VS-300 made its first flight on December 8, 1941.
So you've probably played with a toy like this, and you know that if you spin it in the horizontal plane, it will rise and descend vertically. Tilt it to the right, it'll fly to the right. Tilt it to the left, it'll fly to the left. Forward, backward. That is the basic concept of helicopter control. The problem was how to accomplish the tilting of the main rotors. Sikorsky's design of the VS-300 helicopter introduced cyclic pitch control for the first time in a single main rotor helicopter. It's still the type of control that's used almost entirely, or perhaps entirely, in all helicopters throughout the world. The pilot has in front of him a stick called the cyclic stick, and whichever way he moves that stick, the helicopter will tilt, forward, backward, or sideways. But how does he get the helicopter in the air in the first place? Beside him, in his left hand, there is a collective pitch control lever. We've talked about the cyclic pitch where the blades change their pitch in a cycle. The collective pitch lever changes the pitch of all the blades together or collectively. And naturally, the higher the pitch, the more the helicopter will rise in the air. At the end of the collective pitch lever, there is a throttle control device, usually in the form of a motorcycle-type throttle grip. The pilot will adjust his engine speed by turning the throttle until he gets the proper speed for takeoff, and then he will pull up on the collective pitch lever, and the ship will rise off the ground. To come back down and land, he reverses the procedure. He lowers the collective pitch lever and maintains proper engine speed, of course, by adjusting the throttle as necessary. Flights were made forward, backward, and sideward, and no wobble or resonance was detected. Thus, on the last day of 1941, the VS-300 demonstrated another completely satisfactory control system.
At last, they had it right. The classic Sikorsky configuration had arrived. A single main rotor with full cyclic control, and a small vertical anti-torque rotor with variable pitch. Sikorsky's dream of unlimited freedom of transportation was within reach. But he also saw the helicopter as a means of saving lives. Now, with control problems apparently solved, there was no limit to what might be achieved. Igor Sikorsky had indeed taken the chance to live his life over again. For the second time, he had built a flying machine without knowing how, and had taught himself to fly it. This was the final version of the VS-300, the culmination of 3.5 years of development. The name was still the same, but not much else was.
The recapitulation for the year, written in the flight logbook, tells the story. During 1941, 3 totally different types of control were investigated on the VS-300 with a total flight time of 28 hours, 35 minutes, and 55 seconds.
Let's see what might happen someday after the war is won. You come out of the grocery store, bread, milk, steak, yep, that's the fitting. Back to the parking lot, where you keep your helicopters. Routine by now. Load up the luggage basket. Put on your coat.
Just about I like.
Oh, good boy. Just like the old days of automobiles. And take off for home. An honest day's work done. Here we see the VS-300 snugly tucked in between some automobiles.
How did it get there? The truth is it flew in. And if you don't believe it, watch this. Here is one of the most dramatic examples of the helicopter's ability to operate in restricted space. Please notice that the camera does not once leave the aircraft as it circles in a 360-degree shot. Please notice, too, that the parking lot is solidly lined with automobiles. When veteran pilots see the maneuver about to be carried out, they open their eyes wide, their mouths even wider, and then they grin and say, "Doggone it, I still don't believe it." The helicopter returns and hovers over the space it occupies, which you just saw it leave. It returns, it hovers, and it settles down squarely in the middle. A better parking job than you usually do with your car.
The VS-300A is shown here at its permanent display at the Henry Ford Museum. The person by the helicopter is Les Morris, the first test pilot of Sikorsky helicopters. Fine coverage.
Very good, thank you.
Thank you.
Got two more on our list. Now, but both of these and myself and actually Tony are from California, so it's early in the afternoon. So we don't have a time situation. But Bob Bosler, you're on next.
I figured I wouldn't even speak. I was far on the list. I gave Ray a little write-up of where I was 50 years ago and what I was doing. But I got to thinking about my checkered career here, and I wrote down some numbers of what all happened. And basically 51 years. First 5 years were at Bell. The next 23 were at Command. Then I went to Lucas Western for 15 years, which was formerly Western Gear. And then I've been a consultant for the last 8 years, and the work has not stopped. I told Ray, we're all of us supposedly retired, but none of us are. And I turned in my last report to the Army in February, and I've been busy on other things since. My work has included design, analysis, manufacturing, test, and production. In other words, it never stopped. Now, in addition to that, I was able to perform and supervise research contracts for 7 government agencies. They claimed that when I was at Command, I was the first one to discover you can work on anything you want to work on. You just have to sell it to somebody. Well, I never had trouble coming up with ideas that I thought needed worked on. I produced 4 documents for the SAE and helicopter power plants. And I've been awarded 20 patents and I've written 35 technical papers. So it's been quite a survival, and it's been very interesting. I got contribution awards from NASA and SAE, and I don't think I'm through yet. My ambition now is I'd like to write a book on great ideas I never got to use. There's plenty of them around. That concludes my little discussion. Thank you.
Norm, you're going to wind this session up here. But after Norm does this, what we're going to do is all the pioneers are going to get up here and we're going to get our picture taken. So the pioneers don't go away after it. And then we're going to take a 10-minute break, and I'm going to show you the video that Buck Kelly made on the birth of the Bell helicopter. It takes almost an hour, so we'll do that. As I say, for Norm and me, this is still early afternoon.
Good evening. Excuse me. I'm honored to be here for talk as a pioneer think it was very considerate of the society to have me here on this very day of the 55th wedding anniversary of my wife and me. Okay, hear me better? My first engineering position following college graduation in 1949 was at Wright Air Development Center, Dayton, Ohio, under Bernie Lindenbaum, who was a great mentor in this field of rotary wing. There are several projects that I worked on in the couple of years that I was there before I had to leave for family responsibilities in my home city of St. Louis, Missouri. Developing good methods for performance evaluation at that time was particularly important in light of the subsequent programs that would be evaluated. A very important program that I worked on at that time was the performance evaluation for the proposals for the Arctic Rescue Helicopter competition. In that particular competition, the Piasecki vehicle was awarded the contract of the event, and it was identified as the H-21 at that time. In addition, one of the programs I got to work on was the long-range helicopter tow program for purposes of air rescue. Now, at that time, the helicopters operated at very low altitudes, and one of the problems we had was finding a drogue to which the helicopter could make an attachment. And as a result, we actually had two parts of the program. One was to find and demonstrate the drogue, the applicability of the drogue, and another was to actually tow a helicopter to a point of rescue, at which point, if the operation with the drogue would work properly, that it could be released and go down, make the rescue come back up, attached to the drogue, and be towed back. I happen to be the living recorder, motion picture recorder of the drogue operation. I would be placed in a C-47, held in place looking out of the door at the rear side of the vehicle, and held in place on the floor by the crew chief sitting on my back. There were a number of drogues that were tried flying at the lower altitudes. We had a lot of gusts that would not occur at the higher altitudes where normal air refueling would take place, but Bernie did come up with a drogue that was fairly successful. And I would observe a number of pilots, one after another over a period of time, who would attempt to contact the drogue, maintain contact with it for 20 to 30 seconds, and then fly freely from it. Of the many pilots, at least 5 that I remember working with, there was one pretty outstanding pilot, Wayne Eggert, who made contact under the most gusty conditions and maintained the probe from the helicopter on the drogue and just flew right with it. He would stay with it 20, 30 seconds, move away, and start over again. And there was nothing that could keep him from making contact with it, and he was simply flying an R5 or H5, whichever it was at that time. As far as the tow portion of the program, 4 or 5 pilots had tried or had made they had been towed behind a vehicle. It couldn't be a CH-47 that didn't have enough power to pull an H-5, but they tried with a CH-54. And the procedure would be to take off from the starting point where the helicopter pilot would hover and take up the slack in the cable as the C-54 would move forward and take off. Well, 4 or 5 pilots did that very successfully, taking up the slack. Then, when they were finished, a pilot in the project office who hadn't flown helicopter for a while was asked if he wanted to try it. Well, he got up in the air and he moved along with the transport when he realized that he hadn't taken up the slack. And he allowed the slack to be taken up very quickly. The cable ruptured, flew back into the rotor. He was only about 500 feet off the ground, and that was his demise as well as the helicopter's. That program was followed by further developments. Bernie Lindenbaum came up with a solution to the snapping of the cable by having a weak link at the near the forward end of the probe, so that if it did snap, it wouldn't go back up into the rotor. But again, I had left the area at the time before it really was proven successful. However, that was in the like 1951, and in 1970, one of the supervisors where I was working at that time, it was at Lockheed, came to me and asked if it would be a good idea to use one of the analyses that they used that had been developed at Lockheed for doing an analysis on the tow program. My comment was that that's a case of overkill. There was no need to use that kind of analysis on this particular job. But the thing that really surprised me was by that time, helicopters had been flying higher. They'd been flying they were refueling as conventional airplanes were. In fact, I think there were several Sikorskys that flew across the Atlantic having refueled from refueling aircraft. But that was the end of that aspect of my experience. Subsequently, when I went back to St. Louis, I went to work for McDonnell in St. Louis. And one more thing about Wright Field. Working there as a young engineer, I had the opportunity to meet the upper-level engineering and management of the various companies. Ed Lightfoot came through from Sikorsky. He greeted me as Mr. Gorenberg. Frank Piasecki would come through. How do you do, Norm? I mean, really, very cordial, very outgoing. Then I was, one day, Bernie comes by and said, how would you like to, or Norm, I'd like to introduce you to Bart Kelly of Bell Helicopters. And I was really thrilled with it. And I said, hello, Mr. Belly. I don't know what he called me after that. But in any case, it was shortly after that that I went to St. Louis and I started to work with McDonnell Aircraft. And shortly after I was there, they had won one of the 3 awards in the converter plane competition. The other 2, I think, were Sikorsky, and definitely the third was Bell with the tilt rotor. A good portion when I worked there continued on the XV-1, and I had gone to Wright Field to test the rotor on the world stand there. I had the experience of meeting Stan Martin, who was there on reserve duty in the Air Force, but he normally worked with Bell Helicopter, and there were many times I couldn't be sure that I was working at a Air Force facility or a Bell facility, considering the questions that Stan would ask me. But he was a very friendly guy. But we kept up a friendship for some time. But again, when we had to turn in a report on that operation, where I had tested the rotor on 2 separate occasions for 1 month at a time, the questions I got from Stan again made me wonder who he was working for. In 1959, the work on the XV-1 had been completed as far as what the Army or the military wanted to learn from that configuration. And McDonnell himself was interested in getting into transport aircraft as well as space operation, because his entry into the field had been with fighter aircraft such as the Banshee and the Phantom, and he was eager to expand into these other areas. And in 1959, when the Army was going to do its own examination of vehicles, what had happened was that up to that time, the Air Force had been evaluating rotary wing aircraft for the Army, and at that point they were not going to do that any longer. So the Army had to get in on its own to do all that. And they went through a whole series of tests of various aircraft. McDonnell maintained a corps of helicopter engineers, but he also sent a number of them to other divisions. In fact, one of the early local chairman of the Helicopter Society was very much interested in space, and he went off to work on the Mercury capsule, in contrast to staying with rotary wing. I definitely wanted to stay in rotary wing. I could see working on these other things for a while would keep me employed, but meanwhile I had inquired at VTOL, which was at that point an offshoot of Piasecki. I was interviewed by Bob Lowy, who I saw here earlier this evening, and I was employed there. The point was that VTOL had just won the competition for the CH-46, which was a sea night, and when I arrived there, the company had been under pretty dire financial straits. It looked like a dilapidated dump compared to what McDonnell had looked like in St. Louis. In fact, the engineers were emptying the trash cans in the restrooms because they'd let all the custodians go. But within a year, Boeing picked up VTOL. Now that was a real mixed blessing, and I'll explain. The engineering help were in Seattle, we were in Philadelphia, were really great. They did everything they could to help us. We had the access of their new IBM 7004 computer with which we could saturate any helicopter problem compared to fixed-wing aircraft. The wind tunnel in Seattle was made available, or one of many wind tunnels in Seattle was made available to us, and I would go out on a 2-day test trip and get there sometimes finding that somebody in the fixed-wing part of the company had priority, so my 2-day trip would end up 2 weeks. Sometimes a 6-day trip would end up close to 6 weeks. But in any case, during the day I had access to their computer. The testing was done on the swing and graveyard shifts when electricity was cheaper, and that went on. I came back, I guess it was early 1962, and I was told that I'd used up all the research funding for VTOL for that year. And I said, how could that be? I didn't use the number of test hours I had. I got my costs from the finance people before I went. What happened? Well, I checked into it. They had forgotten to include the overhead, which is 2.5 times the price of the basic testing. Anyway, within a month or so, I was sort of pardoned on that, but we had also had recs out for some 6 people in aerodynamics, and we had already arranged for at least 2 of them to come who had sold their homes. I came to work on a weekend there to do some local catch-up time before the next week starts, and I find a number of Boeing management people there in the company. What the heck is going on here? Well, Monday morning I found out. They came through, so we couldn't hire these 6 people that we had recs out for. And we explained that 2 of them had already sold their homes, that we were ready to bring them in. Well, you could bring those guys in, but forget about the rest of them. But of the people you have working with you, Norm, which were 6 associates, I had to let 3 of those go, which wasn't a very good situation. Well, it developed that 2 of them, for personal reasons, were planning to leave anyway. So I was down with possibly 1 more that I had to let go, but they allowed me to keep him. But here was a company that had maintained a very low cost of operation for several years practically until they got these contracts. And here, Boeing Finance was going to show them how to save money. Well, that was pretty ludicrous at the time. And I had heard of what was going on at Lockheed, bits and pieces, of course, for a while, and Kurt Hohenemser, under whom I worked at McDonnell, was particularly interested because in the early stages of that effort at Lockheed, from what he heard, that much of the gyro operation was associated with a varying RPM, at which point he didn't have much confidence in it. But when they came in and started working with a fixed RPM, his appraisal of it was much better. And so I thought I'd make an application out to Lockheed. The first person that contacted me after I made the application was a fellow by the name of Paul Theriault, who turned that over to Al Yackel, who is here tonight. And within a few months, I was hired to come out to Lockheed. So, as far as what happened at VTOL after I left, I understand in a month or so, Boeing had a problem with their contract on one of the B-52s, I believe it was, where they lost to Convair on the B-36, and all the a good portion of the management that was in Wichita came to take over offices of VTOL in Philadelphia. They didn't know a thing about helicopters. But anyway, in time that improved and the supervisors came back into their original positions. Meanwhile, at Lockheed, one of the first projects I had was working on a contract with the Army on airfoil, a series of airfoils for their use in helicopter rotors. The 63 series airfoils, thicknesses of 6 to 18%. I had done a lot of airfoil testing while I was at VTOL, and I was assigned to do the evaluation on those tests. Shortly after that, one of the projects I got to work on was the XH-51 compound, which was both a useful vehicle for testing the rotor for high speed and high load factor flight. I worked with that, worked on the wind tunnel tests. The vehicle was put together. Don Segner flew it. He flew it at a high load factor at high speed, high load factor or at high speed. The control system worked beautifully. After he flew it, Jack Reeder of NASA came out and flew it. He also found it to be very satisfactory. I went to a forum that year, and I ran into the situation that Mike Hirschberg, a recent historical custodian taking over from Schneider, said that as he tried to make evaluations of the many things that had happened over the first 50 years, he would often get comments that he just couldn't make any sense of it, and they were very derogatory. Well, I'd gone to this forum either 67 or 68, and gentleman from Sikorsky gave a talk on why the Lockheed gyro would not work at high speed or high load factor. Now this was after the fact. He didn't want to have anything to do with reality. That's just the criticism he made. I got up at the meeting and I told him that, you know, it's foolish for him to make an analysis like this that has nothing to do with reality. But in any case, I worked there at Lockheed from 1964 to 1972 was on the Cheyenne. And it had some problems, but both Al Yackel and Ray Prouty gave a good definition of how they were solved. The vehicle worked and did what it was supposed to do, and then it did not get a production contract, and that's been a bone of contention for many years. In any case, I went on to work at a couple of other rotary wing projects. One was on a project with DARPA on a circulation control stopped rotor X-wing vehicle. We worked on that for a while, and based on priorities of the company, we had to leave that effort. And the very final effort I was working on was with a VTOL type of operation for an S3 type vehicle, in which we were considering vertical takeoff as well as short takeoff rumps. That concluded my effort. Thank you very much. I have a few pictures here, if I could show them, and it'd take just a minute. Where do we put them?
We got a technician here. Okay. Just 4 shots. Go ahead. Number 2. This is the X-51A compound with a jet engine mounted on one side and a remains of a stub wing on the other. And that one, Don Segner flew it at 303 miles per hour. His objective at the time was simply to get it above 300 miles per hour. Within a year, Bell flew one of their compounds at 314 miles an hour. But in any case, this was the first one to exceed 300 miles an hour as his intentions were. Okay. We got a couple of, that's an artist concept of the Cheyenne. Move on, please. One more. And that's the Cheyenne in a military exercise over Hunter Liggett campground, where they did a series of military maneuvers with the Cheyenne. That's the end of the speech. Thank you.
Thank you, Norm. Now I want all the pioneers who are still in the room to come over here. We're going to get our picture taken.
Yes. Yeah, from up there, the silver microphone.
Are you connecting the names of the people who are
Yes.
interested in the
You
video?
just put it in the box right on the other side of the TV there.
Right here?
Sure, yeah, that's fine.
Okay.